Hello everyone, my name is Michael Morales and today I'll be showing you how to develop a game using Unity. This video will be for a project supplement for my English class and within one of my college courses. And to begin, I would like just to say that in order to continue further with this walkthrough, you would need to have access to a computer and internet so you're able to build the game on your computer and download the software on the game from an internet browser or on the internet because it will be available on the website that we'll be visiting later. So the first thing I'd like to talk about is how would you build your game? You might want to consider the game engine or the engine that will run the game. And the point of a game engine is to have a system of a way to control your mechanics. So there's already public game engines that are already made for new developers and realistically anybody that wants to make a game. They have multiple ones already released, and I say this because when you become a professional developer or you're experienced, you might want to make your own at that level. But as of right now, it's always best to start with one of these new ones that are available for everybody. And in our case, for this tutorial, we'll be using the Unity game engine. This is a game engine that you can develop a game in a 2D space or a 3D space. So 2D games or 3D games. And there's other ones here you can see that you can also take a look at. But we won't be really talking about those. We'll be mainly talking about Unity. Unity is one of the more popular ones to visualize what you're doing and working at the same time while you could be coding. And it's just really intuitive and easy to learn for just about anyone, whether you have no prior coding knowledge or coding knowledge. It's quite easy to pick up if you're really interested in it. And yes, so we'll continue with this game engine. And like I said, it's highly recommended to begin with one of these or any other one that might be public and openly available with good documentation and tutorials online. Um, you don't want to choose something that's too outdated or there isn't too much documentation to learn about from because these are engines made by other people. You want to learn the most you can about them so you can make your game. All right, so we'll want to download Unity. In order to do that, we need to open a web browser, whether you have Internet Explorer, Chrome, Firefox, whichever, just any internet browser. Let's open it, and we're gonna type in the link for the address link for this website, www.unity.com. The link will be provided in the written notes you'll be looking at later or during this meeting. So we'll get presented with this page. This is the Unity Game Engine website. There's a bunch of stuff you can look at here to learn more about it, but where we want to go next is on we want to click on the Get Started button so we can look to where we can download the actual software. And here we are presented with an individual and business plan, or plans I should say. And obviously we're going to go with the individual tab because as you can see, these are all priced and they all cost money. And the reason they're priced and they have, you have to pay for them is because they come with more benefits and more professional benefits that you can use once you are really experienced with this software and you want to create a team or something big for a company or a studio. But we're not going to be doing that right now. We're going to be doing some individual work, something small and simple. And you could choose student on your own, but you have to get approved for this as well to get verified that you're a student at some institution, whether it be in high school or in college, because it does say in age 13 in the U.S. I'm assuming you can go in high school. This was something new, by the way. This wasn't here when like a few years ago. This is something that's recently added for students. They come with a little bit more benefits than the personal version, but everything we need is in the personal version as well, and you don't need to get verified for anything on this one. So, and it's also free. So, and the only requirement that you have to notice here is that the eligibility is to have a revenue or funding less than 100K in the last 12 months. Meaning, if you make a game, it has to be within this boundary, this boundary of receiving your payments. Just how much money you would make would have to be less than this amount, and within a year, for using this version. And like I said, the other versions they'll allow you to have an unlimited amount or just a higher amount of revenue gain. So we'll click on Get Started, and you'll be presented with this page, which will ask you if you're a first-time user or returning user. And the difference is for choosing this download is just that you would get a bunch more tutorials and other things, but it's gonna take a longer download time to start with this one. If you would like to download this on your own time, like another version, you can do this one. But realistically, these are just pre-made tutorials from the company. I wouldn't really recommend using these right now. We won't be using them, so we want to have this downloaded quicker. So we'll be acting as a returning user, and we'll just ignore this. I mean, if I'm trying to teach you guys this and you guys don't know already, then you won't have experience. But we just need the software, and we'll get started. So click on Go here on this right tab, and then we'll be presented with the Get Started with Udemy personal page. And the next thing you'll have to do is accept the terms of service before being able to download this, because it won't let you download the software until you accept it. And basically, it's what we already discussed. You have to make sure you don't make more than 100K in annual gross revenues, regardless of whether Unity Personal is being used for commercial purposes or for some internet project or prototyping. You cannot exceed that amount. You have to make it under this amount. And it states that again here. And you cannot be using another version or upgrade of Unity. If you're going to be using this one, you have to use one version at a time. That's just part of the agreement here. If you want to use another one, you'll have to switch down and accept those terms. And there's some other eligibility requirements. And your system requirements for your computer to run this app, they'll be presented here. You want to at least have these minimum requirements to use the software. Otherwise, it may not run as well. And most modern computers won't be able to run the software. It's relatively not that demanding. It depends more on what type of project you will create in the future that might end up requiring a more demanding computer in terms of specs or specific requirements. But you'll be fine. So let's download this software by clicking on Download Unity Hub. And it'll take you to Let's Get You Started. Thank you for downloading Unity. And you shouldn't be able to do anything. You shouldn't be able to click on any of this, or you will be able to click on it, but you don't need to go anywhere. It will automatically start downloading for you. I already have it installed and downloaded, but I'll still run through it as if I was downloading and installing for the first time, just to follow the format I've created for you guys on the written document. You click on it on the bottom, and it's gonna probably ask you, because you'll have security and user account control on your computer, if you would like this app to make changes to your device. You will click yes. This is a verified and official program that will not contain any or do any harm to your computer. And then once you click that, you'll be presented with a dialog to accept the terms of service, which you would want to read, because that is a requirement having to read this. And then I read it and took a look at it. So once you accept them, you can click on I agree. And then you would want to install the hub. We're installing Unity Hub, and the idea of Unity Hub is more of a separate app to control the actual software we're going to be using, just so you can interchange between different versions. This is something new, and it's not complicated at all. It's just part of the prerequisite to installing the actual software. And you can choose the destination folder here of where would you like to save this on your computer. And it chooses a default one for you, which is in your C drive on your program files. So you might just want to leave that there. Unless you know somewhere else you would like to change it to, you can do that. But other than that, just click install. And yeah, in my case, I had the application already running, so I had to do that. That should not pop up for you if you guys did not already have it open or installed. So you just click OK, and it would install, and then it would automatically run if you have this check mark open. As soon as you finish installing it and you click finish, the app should be opening. And we won't need to have the internet browser anymore. We will have to close that. And then it would most likely, if you have Windows Defender Firewall enabled, it will tell you that it's blocked some of these features from this app. And the reason for this is because the app is able to use internet accessibility through downloading things within the actual software or integrating some type of online network within your game. It's going to be asking you to accept these things before you even start using it. And once again, they don't do any harm to your computer. You would allow access. Make sure you're on the administrator level of your computer, security level. And once you allow that, you should be good to go. The Unity Hub will be presented here, and you should be presented on the Learning tab, which we won't be looking at today. This is just something extra if you guys continue to want to learn how to make other types of games. Alright guys, one quick thing here I forgot to add when originally recording this video that I'm going to include a cut here is whenever you finish installing the Unity Hub application that we just finished going over, the first thing we actually want to do before we continue on with anything else, you'll probably still be on this Learning tab here, but we're going to first go to the little top right. We have a little person icon right here that would, if we click on it, it would show our account, Unity ID in my account. And there's a little icon here that basically we want to create a Unity ID account so that we're able to actually make projects within our hub, within our editor. Because if we don't, if you weren't signed in and you weren't already signed in before, if you try creating a new project, it wouldn't allow you to do it. It would tell you that you need to have some sort of license, some Unity license. And if you get that error or problem whenever this is finished installing and it shows to you, and the first thing you see is you need a Unity license, there would be an option, right, that should if you would probably be on this let's see, yes, so I have my license here. You might have something similar like this to where you would want to have some manual activation, right? So you would want to click on that, and you would want to well, no, in my case, this would be my license here that would have to manually activate. But since the license is given to you when you're signed in, right? So you would click sign in. Now the thing is, you would want to create a Unity ID. So you would, if you had one already, you wouldn't need to worry about making one. But since most of you might not have one, you might want to create one. So you just click on this create one link right here. You would have your email set up. You just put your email in here. I already have my own, so I'm not going to be typing anything. But you just have your email you would like to use. You would receive a confirmation email on this address that you'll have to go and look to make sure that it's a real email. They want to make and verify that whatever email you're giving them, it's real. So you'll have to put in your email here, make up some password, and they have the requirements here. Create a username so that whenever you're on the community page on the website, they can see what your name is, and your full name. They want to make sure that they know who they're working with and who they're going to be using, who's going to be using their software, so they can contact you, the actual developers of this game engine. So that you would put your full real name here. Make sure to check these boxes that you agree to their terms. And you, like I said, you probably won't have a Unity ID already, so you wouldn't be on this page if you had one already. So once you were done, you would create a Unity ID. I didn't try these options, sign in with Facebook or Google. I wouldn't try. I would say just keep this separate from those things. But you could try those if you would like to. It would sort of skip all this process, but I made this manually because I wanted to keep this separate. So once you create a Unity ID, it should allow you to it should log you in now. So basically you would have this thing where you can go, it would be on your preferences page, and you would go onto your license management, and you would have some activation description here, and it would say which one you have activated. The personal edition that we selected, this is the one we chose when we were on the website. And once you're logged in, you would have you can use your license, or you can use the actual project. And once you create it, if it didn't already log you in, then you could just sign in, right? And I already showed you how to do that. You just go up here, sign in. So now that you made it, you would just sign in with your email and password, and this should, and every single time you loaded it, it would already be signed in. You wouldn't have to be constantly signing over and over again. So you would sign in if it didn't already sign you in, right? So once you are signed in order to go back to the main page, just click on this back arrow preferences. So now you should have your account already here signed in to whatever you made it. And now, if you were to make a new project, you wouldn't get any errors telling you that you would need to have a license activated, or perhaps in the next step where I'll explain how to install the actual software, in case it did tell you that you would encounter any problems because you need a license, then now that can be covered by you creating that account that we just went over. And I'm currently logged out just to demonstrate how it would look like creating the account. And but for the actual project in the next step, I would be logged in already, and my license would be active as I'm using it. But yes, guys, that would be the part I had forgot to include in the original recording, and that is the cut for right now. So we'll move on to the next part, where we would be explaining how to install the actual Unity software. And we'll resume back to where we were at on the Learning tab once you're done with that. So now we'll be going to installs. And here I already have this Unity version because I've already previously used it. But we can always add a new one, and I also need to update to a new one anyway. So the first thing you want to do, since you will have no projects, I have some here because I've used it already, and same thing with the Unity version, you would want to go to installs. You would be on the Learning tab when it first opens. Go to installs, click on add, and then you'll be prompted with the recommended releases, official releases, pre-releases of different Unity versions. And recommended releases are usually the most stable ones, and the official releases are too, but these are just probably more common and used. In our case, we could just use since I already have the other one, this version, we could just use the official release, which should be ready. This one right here, yeah, Unity 2020.1.7 F1. Click on next. Alright everyone, I'm going to make another quick note here when installing the Unity game engine software, is that there's actually a crash bug in the 1.7 version. As you can see, I have 1.8 here, 1.7, and for 4.2. This version right here, it's sort of like bugged, and when you would create a project, you might have an error that might say something like couldn't load this custom layout, and it won't let you further continue using the application. So for example, you would have something like, oh, right here, so you would go in this version, you would make a project, right, create, and sometimes it will work. When I first did it, it worked the first time when I was making this video, and when I had some testers and people test this out, turns out there was some errors that came out where it would not let you actually open the project again, or sometimes not even make it for the first time, and then I couldn't reopen anymore using this version. I just want to show you guys the type of error that actually appears when it's building the project, if it shows this time. I re-upped my software, or I re-updated Unity to the newer version that deals with this, and yeah, okay, there it is. So you're gonna get this error. It's gonna say you have some custom window layout that you don't have. It's just some bug and some wrong error that won't let you actually get through it. You have to quit the application, and you can't actually open your project at all in this version. So what you have to do to fix this, there's multiple ways, but the easiest way that the actual developers of this game engine, Unity, they updated the game engine to 1.8 and 1.9. Well, it's at 1.9 right now, but any version that's newer than 1.7, so 1.8, 1.9, etc., those they fixed the bug already, so you won't have that problem. So if you started watching this video when I explained it to be installed at 1.7, all you have to do is just go to your installs tab, go to add, and instead just click on the official release. So probably say 1.9 for me right now. At this current time, it's 1.9. Oh well, not this current time because this is where I'm editing it, but later on there will be a version that's not 1.7, and you would download that. So you download that, and once it's done, all you have to do, it'll show here in your list. Go to projects, and where you see your old project, it's 1.7, just click here, click on 1.8, and now when you reopen it, well, it's gonna ask you that it needs to upgrade your project. So this basically fixes the corrupted project, or the error that you were getting. And like I said, 1.9 also fixes this too. Just any version above 1.7 will fix this error. And like I said, when they made the original video, here it is. It opened on my other window. So see, no errors came in. There was a little error down here, but this is something else. So basically, your project will be fixed once you change it, once you update your Unity version. And this fix came out not too long after the 1.7 version. It was really big. It was happening for everyone using the software. So just make sure to update it and to go here once you update it, and once it finishes installing, go to your projects, click on the project that was 1.7, and then click on the latest one that you download, which will probably be 1.9. I have 1.8 here because once again, these updates come out relatively fast once there's a lot of reports and feedback from users. So you would update it, or you can also go here. If this is the first time, if you're a first time user watching this video, just make sure you install first just the 1.9 version. And I mean, it doesn't give you the option to go back, but if you do have that there, don't do it. Just install the latest one, the 1. Anything above 1.7, anything but 1.7. I believe also versions before 1.7 were good. 1.7 was just a corrupted version. So you would do that, and then go here and make sure. Here you can create a project, or here to make sure when you make it, you choose the version you want. So obviously don't choose 1.7, you would choose 1.8. So for example, if we made a 1.8 version this time, I showed you how I reopened it and it fixed the old project. But now if we just make a new project in 1.8, then it should work. You should not encounter any error pop-up that won't allow you to continue. And the other way I mentioned to fix this was it's way more technical, and you have to do this. You have to do that for every single project you do. This method works all the time, and it's the best one because it's easy and you won't encounter the problem ever again once you update the software. Or at least if you do, you're just gonna have to wait until they put out a new version. They do it really quick, and as you can see, it worked. So yeah, just in order to fix that problem, you just need to update Unity to something above 1.7, 1.8 or 1.9. The latest one should be 1.9, or if not, you can just get 1.8. And that'll fix your old project. You just switch to Unity version, and you should be good to go. Alright, and now we'll continue further with the video. Next. And then for modules to add to your program. So basically, we're going to need an additional program that goes along with this software, because you'll have your actual Unity editor to make your game, but we also have to code a bit on a separate app, on a separate editor, similar to Notepad or just some other editor. Just think of it as like a place where you would type an essay, or you just want to have your a separate app to contain all your code. This is specifically for code. And we'll be using Microsoft Visual Studio Community 2019. If there's another one here that is there, I mean, just select the latest one. So I already have this installed. You would just click on that, and it would update. Android build support, iOS build support. These are optional. We won't be using these two. These are only if you would like to publish to these platforms. But you just need to have the Microsoft Visual Studio Community 2019 checkmark because we want to use that as our external tool. You would probably want to have these three: Universal Windows Platform build support, WebGL build support, and Windows build support. Documentation is also optional. So realistically, you should only have 4 checkmarked at the very least: Microsoft Visual Studio Community 2019, Universal Windows Platform build support, WebGL, and Windows build support. And like I said, these are just optional. And even if you do click them, they won't affect or not make your program work in any way. Just make sure you have those 4 installed. And then we would just click on next. You would be sent to this link to open and view the terms and agreement, license terms. You can just read these later on your own time. And then once you accept and read them, or read and accepted them, you would click on this checkmark to verify that. Click next. And then you would be, if you are installing the Android bundle, or the one I just showed you for Android and iOS build support, you might be presented with another page. And I will have that because I currently develop on those platforms. But like I said, you do not check those if you do not look forward to doing that, because in this case, our game would not be on any other platform other than our computer. So once you click done and accept them, you will be prompted again with a security question to accept the permissions of this app to move along to install this program. And you click on yes, and the download will begin here. And you would have to wait a little while for it to download. It really just depends on the speed of your internet, and in my case it's moving rather quickly. I also have most of the prerequisites already installed from the previous Unity version, and with modern applications nowadays they just update what's already currently installed or on your computer. So it might take a little longer for you guys to install this. So don't be too worried about it. It just will take some time if it's your first time installing it. And in this case, the next thing we'll be looking at is to create a new project within this Unity version. We want to make it allows us to organize our projects. Our projects will be our games. And as soon as this finishes installing, we will continue on with that. And like I said, it might take a little while longer for you guys to install this. You just gotta be patient. And the cool thing about this is you can have as many Unity versions as you want that are available to you. Sometimes you might want to go back because you have a project that's outdated, or it's a certain version, or if there's something you don't like about the newer ones, you can always go back to the old ones for your own comfort and use. So that was showing it downloaded, and now it's showing that it's installing. Should be finishing any time now. And like I said, the learning tab has a bunch of resources you can continue to look at. Different games, tutorials, projects, they go over everything in different sections in depth, way more in depth than I would be going into most of Unity. I would be only covering the basics. These also cover the basics, but in my opinion, they cover a lot more than the basics for a first-time user. And you also have the community tab to look for information and get help, forums, answers, everything. Should be almost done installing. Okay, now that the program has finished downloading, we can now create a new project within this program version. And like I said, this can take a little while depending on your speed of your internet to download it and your computer to install it. Well, realistically, to install it, it's probably the same on all computers. There's just a lot of things it has to install since it's the latest version of everything. It'll just take a long time no matter what specs you have on your computer. Just make sure to have good internet to at least cut the download time by a lot. Alright, so the next thing we'll do is click on this new tab in the projects tab. We were in the installs tab. Now we're going to go to the projects tab, and we're going to click on the new tab so we can create a new project within this software. And we're going to be making a 3D game. So we're going to make sure the template is 3D, not 2D. We want to have it selected on 3D. And for the project name, that can be anything you would like. The game's going to be a rather simple one, and it's going to be more aimed toward a roll of the ball game. I'll show what the game is right now, but let's just call it 3D ball game. It really doesn't have. It could be anything you would like. This doesn't really matter. It can be saved in a certain folder that you can have. Where would you like to save this? You can change the destination here, or just keep the default one that's already here. I have it within my documents folder inside a folder called Unity Projects that I made myself. So it just wherever you would like to have this saved, it would be saved there. All right, once you're done with that, click create, and then the project will be generating, and the game engine, the app will be creating your template and everything for you. Just give it a few moments to do this. And once again, this is about the same time it would take just for any computer to handle this. This is more on the performance of the app rather than your computer once it's already installed and ready to go. Certain old computers might actually be able to have a lot more trouble booting these type of apps up just because they require a lot. But usually, the latest version of these apps and software, they wouldn't let you install it on those devices because they would be too outdated. And they'll let you know, as I've said before, on the OS requirements that we saw on the webpage earlier. It would tell you what at the minimum requirements you would need for a computer to run this. Anything that's below that would have a lot of trouble, would not let you download or run it, and you would probably have a lot of trouble. If you see this, just close it out. We already have the latest version, and I think actually there is a small little mistake here. I'm gonna exit out real quick just to make sure there's not any errors. Okay. Yes. So once you get to your projects tab after the installs tab, just go to projects after you install the latest version. You should only have one unless you already been working on this before. You would want to make sure your game is in the latest version that you just installed, and that would be the 2020.1.7 F1 version. You might mistakenly forget to choose 2020.1 when you create one. You might just go with the lowest one you had before. Once you do that, you can, even if you created it by accident with the older version, you can always upgrade your project to a newer one. There's certain things that you need to rebuild, and usually you won't have any problems with this. Unless it's a big project and it was really outdated, then you might have to relook at some things, but you can just rebuild it and change the version to whatever the new one you downloaded to. And you would give it some time to do this. And both, like I said, the 2019 version are not much different. You'll still accomplish what you want to accomplish in making a game within this game engine software. It's just you have more convenience of the latest updates and convenient additions to the editor that might make things a little easier. So you would always want to get the latest one that's stable. Unfortunately, for this free version or personal edition of Unity, you'll only be able to work in light mode. There is no dark theme mode or changing of themes. You would have to... Oh, well, actually, I take that back. This is the 2020 version, in which this is something new that I did not know about, because all versions before this, all your versions before this, you utilize the light theme only, and you were not able to change the dark theme or to any other theme, and now they made it available for everybody to use, which is great, because you looking at the light theme for quite a while can be tiring for your eyes and a little straining. But I'm really glad they did this. This is quite the surprise. I was using the 2018 and 2019 version for years. They've had this for a while, since a beta a few years ago, but I didn't want to switch to that version because, like I said, if your project is too big on whatever game you're making, you might have to make a lot of adjustments and you might get too many project build problems. So I stayed in the older versions, and like I said, that is also fine, but this is a great example of what I just said. Whenever they add these little convenient additions to the editor, it can really make a big difference for when you're developing your game in this environment. So with that being said, we already have our project view open, and I would like to next discuss how the interface of this software works before we continue further. So the first thing that I would want to note is that we have a bunch of tabs and areas in this software that open more tabs and more options for us to choose from. So this can seem a little overwhelming at first, but it actually isn't. And once you get the basic understanding of the main tabs, understanding the rest of them will be quite intuitive over time. It'll just take practice and some further look into it. But we'll be discussing the basic ones here. And for the first one, we'll be talking about the hierarchy. There would be about 7 tabs that we'll be talking about. But the first one we'll be talking about is the hierarchy. And this one is basically the one where anything you put in your game or into this area right here, this view, it would be listed here, right? So our project is called a sample scene. This is just the name of our project, of our scene. And within this, we have a camera and a directional light object. Anything in here is that would be called a game object, and these are game objects. They all do different things, right? But the point is for a hierarchy is to organize and lay out anything that you put into your game world. It would be shown here on this hierarchy, and you can drag it out and move it around everywhere. When you have a lot more game objects, you would really want to have some nice organization to be looking through your list of items here. So this is what the hierarchy is for. It's just managing your game objects, and like I said, game objects are just more of what the name says. They're objects that are within your game. So, and they would be shown on this screen right here in this view. As you can see here, it just points out what this is. That's a camera. It's invisible, but it works as a camera. The light is just where you want to have the lighting within your game. All right, so that's the hierarchy. Make sure to keep note of that. Then we have the scene view, which is what I've just been showing you so far. Right here, it says scene. The scene tab is your game world tab. Everything in here is where you'll be designing and making your game. And it's for you to edit and move around. So you can actually scroll around this this view, because right now you're in place somewhere. You're in the first person view where you can just look around. If you right click your mouse and hold onto it, you can turn around in any direction you would like. But you also would like to move around in this space, and you can by clicking the WASD keys on your keyboard. You can, W would be to move forward, S to move backward, D to the right, and A to the left. And if you want to turn around, like I said, keep holding on your right click on your right button on your mouse, and you would be able to move around freely. And these grids are just more of the measure and design layout for when you build your world. This is a coordinate system. As you can see, there's a X, Y, and Z plane here because we're in a 3D space. So you have these three main coordinates. If it was 2D, it would just be X and Y. So this is basically how you just move around, just get comfortable moving around the scene, because this would be really useful later on for when we have to make edits to any game objects we use on here. Anything we place in here, you would want to move around it to sort of click and get things straight. So like I said, WASD is to like freely move around, and you hold on to the right click on the right button on your mouse, and you'll be able to freely move around. One last thing to note is that you can also zoom in into the scene, which you can do this by scrolling up and down your mouse scroll bar, or scroll button, I should say. And this is also very useful because you could get close to it manually yourself, but in case you want to look at something very small or not travel to that area, you can just zoom into it and zoom out. Very useful tool. But this is basically, those are the three main mechanics you want to be getting used to and controls within this scene view. Like I said, this is the main tab you'll be editing all your game in, all your game objects in. The next main tab we'll be using is the game tab, and you can get this tab by just clicking. It's right here, the scene we were just on. You just click on the game tab, and it'll be shown right here. And this will just be an empty white space. There's not really much you can see. You would think you would be able to see something like this where we're walking around in, but it's because the game tab shows what the camera is showing. And right now the camera is put in a spot where you can see the preview right here in the bottom. There is nothing to show because we have nothing placed in our world. This is just an empty space. So there's nothing to show on the actual game view. And the game tab, the difference between the scene and the game tab is the scene is where you would edit everything in your game, right? To place anything. The game is just showing from the camera's perspective everything you've made already. So kind of like a preview of what your game will be before you actually playtest it. You can't really make any edits within this game tab. It's just more of your playtest and running your game tab. And like I said, you would be able to see a preview where you would start in your game if we had stuff in our camera, or if we moved the camera somewhere else. But for right now, it's just going to show an empty space. Alright, so the next tab we'll be looking at, the next main tab will be the fourth one. This will be the asset store. We won't really be going too much into this. I mean, it's more of just an external tool just to download assets. You know, if you want to download certain graphics or art for your game, you can visit the asset store. And it says right here that they have moved it and they worked around some certain things. Yes, so it says right here as what it's saying is that they only made it so the asset store is available through the web, and you have to download it manually and import it to your package manager. So unfortunately, this may be a con just for the fact that before in the previous versions, you were able to just have a preview of an open like of the actual website through here on this tab, and you would download it and it would just immediately import any graphic you would want into your project. But now they're saying they have to improve the performance in the editor because this will actually decrease performance. I remember it would sort of slow down your use in the editor and things will sort of glitch out or take longer to load. So they want to make sure the editor runs as smooth as possible. It's like it makes sense why they would do something like this. So because of that, it makes even more reason that this may not actually be a relevant tab anymore. But it was one that was definitely relevant in the past, and it still is relevant because it lets you know that there is the asset store still available. You just search online, right? Click on search online and it would take you to the actual store, and you would be able to download anything you would like that's for free or paid. So you can still work with that, but we won't be using any of that because we'll just be creating our own graphics within the editor. But yes, you can still have that tab there or close. You can also right click to close or add tabs, but it won't worry because it won't really bother us. We'll just click on another one and it won't get in the way. Next tab to go over and to learn would be the inspector tab. This is a critical one. And the inspector tab, like I said, all these have names in the top, so they're really easy to locate once you're given a name. So there's no inspector tab on this side, but on the very right, we can see a tab that says inspector, and this is the tab we're looking at. And the idea of the inspector tab is whenever you click on a game object from our hierarchy, right, from our list of items that are in our world, it shows the properties of that game object, because you have that object, but you want to change values and properties of it to make it do certain things, and this is what the inspector does. The inspector shows different properties of that game object, and there's a lot of properties that you may be very unfamiliar with here. It may seem overwhelming, but I'm just trying to show you that we will be using this tab a lot to access certain properties really soon and later in the tutorial. So this is where you would go to change any values. You just click on it and the inspector tab's over here. And the next main tab to go look forward on to, well, before I go to the next one last thing is the add components for this. It's also technically more properties that you would add to an existing game object. So you can click on add component and add a bunch of new things, but that's something we'll go into later. It's just another idea I wanted to just point out before we move on. And now we'll move on to the project view tab, which is another main tab we have to know about. And like this may seem overwhelming, but like it's really just understanding what it is, and it'll just become natural to understand once you are given the explanation. That's what I'm trying to do for you guys. The project tab is basically your similar to the hierarchy, but more of carrying your files in folders of what you have up here. So basically anything that's up here, you organize that's already these objects are already active in your game, or they're in your scene view, they're active. Anything that's down here is not active, and they're sort of in a placeholder or a folder, and you would have to drag anything from here onto this active hierarchy. So these are all, this project view acts like a hierarchy, but this is more similar to maybe what your file explorer might have, right? You might have sort of a just organization of keeping things saved. This is where you would have these things saved for your game. And you see there's already a folder named scenes here, which is, this scene is just what I just said right now, the scene view. It's just your game world. And it's called sample scene. This is already pre-generated when you create your project. So yes, this is the project tab. And the final tab we will be discussing and talking about to use in this tutorial will be the console tab. And basically, when every single time you play test your game, right? You play test your game by going to the game tab. Well, you don't have to go into the game tab, but you would want to see it in the game tab. You have your console tab open. You would click on this play button up here, which would run your game as a way of play testing it. And it would run. And when it's blue, it means it's running. There's nothing happening right now in our game, so nothing would be showing different. And once you would have stuff loaded into your game, you might see console notifications in the bottom down here letting you know whether something was wrong, an error, or if something ran successfully. So This will be very important to know whenever you have errors or something would not be working right. Check in the console. You can also, if the console becomes too big or it spams your view a lot, you can just click on clear and it would just clear everything, and until you run it again, then you can see the notifications. And that would be the 7 main tabs we would just have to understand and know for this project. So you'll have your hierarchy to organize your active game objects. You'll have your scene view, which you can edit and add and move around things in your game world. You can WASD move around, hold right click to turn your camera, use a scroll bar to zoom in and out. There's other, and the thing is, when you're using these things, you see this little tab up here that sort of just shows what function you're using in this view. When you right click, it shows you're using a handle, but your hand, which it shows you here on your mouse, your mouse pointer, and then when you use the WASD, it shows that too as well, but it's because you're using the right click, you're using the right function on your mouse. There's other things here you might be able to see: scaling, rotating, rect. We won't really be using these. These are just more specific edits on your game, but they're also very useful. We'll just be using these two that keep switching interchangeably. All right, so the next one we had covered was Game tab. This is just the tab that we'll be running your games on, and you can play test them by clicking play. And this would not be something you can edit. You would have to go back to the scene view to do that. You would just be seeing everything, your preview. This preview is your main camera that shows what's going on, and there's nothing here, so this is why it looks like there's nothing here. And the next tab that we went over was the asset tab, the asset store. This has been moved to only online, so you will not be able to access it within the editor anymore. But it's something great to look at if you would like to add anything else into your game. And the inspector tab is the one that appears when you click on the game object on your hierarchy to change any properties or add any components. And then we would look at the project tab down here in the bottom left. This would be similar to your hierarchy, but to more of a save your files of your game in a folder and just have really great organization to access anything that you would like to add into your game. And lastly, you have your console tab, which would be showing your output, your errors, your success runs, certain notifications that the editor is letting you know about when you're running your game will all pop out here when you click this play button and play test your game. And with that being said, we will already be done with covering all 7 main tabs and user interfaces on this game engine software, or this editor I should say. So now we'll be moving on to actually making the game. So for making the game, I want to give you an idea of what the game's going to be. I had to make something simple so we can cover and not take too long on this tutorial. So I would like to minimize out of this real quick, and I already have let me see real quick, a screenshot of the game right here. So the idea of this game is just to create a box space. This would be your world. We'll be making this world right here, this blue line, these blue boxes or rectangular boxes. We'll just create like a border, sort of to enclose and keep your player, and your player or the character you'll be controlling is this ball right here, this red ball. So you want to make sure it doesn't fall out of the world, right? So we create these little borders here. And the idea is that you would have to control this ball to get around these little walls here to reach the exit. This green block, when you touch it, will be the exit and the winning factor within your game. If you're able to reach that, you win the game. And these purple walls or barriers you might see here, they're indicated different color because they are the obstacles in the game. We want to make something a little challenging within the game to sort of create some more excitement in a challenge. So as soon as you would touch these walls, you would die, or the game would reset, I should say, and you would start from the beginning position. So you would move around here, move around here, move around here, and as soon as you reach this exit, and it's also indicated a different color to show why it's that. It could be any color as long as we want to just sort of differentiate every single object that's in our game to have a better understanding. So once you touched this block or collide it into it, the game will show that you would won, and you would have the option to restart or just close the game. So that's the idea of our game. This is already pre-made and preset because I want to speed up the process of teaching you how to actually use the editor to make something like this. And making the idea for making this type of game, this is more of just a plan out. The brainstorming part in making a game is very crucial and important when you want to make a game, but In our case, I just need to sort of have this ready for you guys so we can move along to actually learning how to use the editor. And with every game you'd like to make after, you would just brainstorm on a piece of paper or anything you would like. And then since you already have learned how to make another type of game, then making that game would be very intuitive just because you're already familiar with the editor and the code. So that's what the aim is here. Not so much on designing what type of game you would want. That's just more on a personal preference. But I chose something this simple so I can teach you guys the basics of what I'm trying to go over here. And like I said, that was the game right there. And I have a game flow chart here that just basically talks about the flow chart of the game flow chart when it comes to making a game. You come up with a concept in your head and then you sort of design it on something. You would prototype it, and the prototype would be what we'll be doing in Unity, making a prototype. You would play test it until it works correctly and there's no problems, and you would get sort of an evaluation for when you might want to review it or have other people review it and just recheck it over and over again to see if it's getting better or not, or you want to improve or get rid of things. And then doing these repeatedly will create an end result of your game. You would just have this cycle of doing these tasks and ideas over and over again to create your game. It's never just one run. You just, like I said, constantly do this to keep updating your game and make additions or changes to improve it. So that's the idea of game development, and this is the game we'll be making. That's why I said simple 3D ball game. You know, you're rolling, controlling a ball to reach a certain exit to beat the game. This is our level. This is our game world. All right, so let's go back into the Unity editor. Like I said, I just minimized out. I did not. It's already enlarged, and I did not exit out. If you exited out by accident, just go back into the Unity Hub and click on your project. In order that you just click on the Unity Hub, and it should pop up right here. You just click on it, and it will load. But I already have it here. All right, so for this project, I'll go over it and design it from beginning to end. If you would like to use it, this idea of this project for your own use or continue it, you may. This is more of an educational project. I don't really see it as something professional for me to use in my own personal project list. I mean, it's not something that I would copyright or put down. You guys may be able to use this at your disposal. All right, so let's first think about how we're going to make this game. So we want to create the floor, or we want to create a base ground, because in that picture that I shown, right, we have this blue border and we have this blue ground. We want to make the base level, the actual level ground for this game, and that's the first thing we're going to be looking into. And in order to do that, the first thing we want to do is add a plane, and a plane is in coordinate plane terms, it's just a flat piece of ground. It's just an object, right? A 3D plane. So in order to do that, we could do this two ways. We can click this tab up here named Game Object, go to 3D Object, and you will see this option in plane. Or you can right click on the hierarchy, 3D Object, and you will see plane down here too. I would say it just saves you an extra tab of clicking, and it's just a little quicker if you just right click on the hierarchy and you click on plane. And this is more personal preference, but I'll be doing it this way. So you right click here, 3D Object, click plane, and here we go. We got a piece of land here, and it seems that it's under the ground or under the grid. So we want to make sure. Sometimes this shouldn't happen all the time, but it works. It might happen it might appear different areas for the first time when you create it this way. So in order to fix this, we want to have it at the center of the world. And as you can see, when we click on the plane, as we discussed earlier, it shows the inspector properties. And it shows that it already has some inputted values that we do not want here. We want to have it at 0, 0, 0. So you can manually type in 0, right? You click on it, highlight it, click 0. Or you can click right here, and there should be a reset or reset position option. You can click on reset position. And this was a little 3-dotted tab right here. This is the same thing as inputting, like I said, in each value or each text box, you would put 0. And the reason for this is we want this item to be at the center of our world. We don't want it to be anywhere random that the editor created for us. We want to sort of control that, and we have that ability by changing the transform. The transform is the position, rotation, and scale. These are all different properties we'll get into. But for right now, the position is the first one we're talking about. Just coordinates, X, Y, and Z coordinates. And you can see right here, this is where it starts at the center. So now we have our plane. It's great. But now we need to figure out how we're going to add those borders. And in order to do that, we would like to add another game object that we just recently looked at. This can be you would go to 3D object, right? And we want to create something that looks like a block or a barrier that's square, rectangular. And in order to do this, you have a cube. You would click on cube. And once again, you might want to go click on the cube. It's going to spawn it somewhere or make it appear somewhere unordinary. You would want to go to the click on the cube, go to the properties, go to the transform, click on these little 3 dots, and then click on reset position, and you would have it pop up here. And it's a little weird looking on the side of there's a lot of shadows going on here, so it might be a little hard to see. And like I said, make sure that when you're looking at this scene view, right, you can move around with WASD and hold your right mouse button to freely move around. This will make it really comfortable and easy to make changes to your game objects. For example, you click on this, right? So you're actually able to, once you add them on the hierarchy, you can click them in the scene, and it'll actually highlight them on your hierarchy as well. But sometimes if there's too many, it might show the wrong one, and it's always best just to look at the one, just to click on it from the hierarchy so you know which one you're working on. So you click on the cube, and it appears halfway in the ground. We want to bring that up a little bit, and in order to do that, we need to drag this little y-axis up. And I think with doing this will work like that, and you would have the cube up. But it might not be exactly precisely up. It might be a little floating in the air, and that's fine. But we want to be just as precise as possible and accurate. So we're just gonna go click on the cube, go to the inspector, go under transform, go under Y, and it's at 0.53. It was really close to the value I was gonna set it at. We just want it at 0.5, and there you go. We have it. We should have it perfectly right above the plane or the ground level. And there you go. You just learned how to add a plane, any cube object to your game. And this basically already has our, we would already know how to make our level, because you could just add more cubes and sort of just line them up all around, right? But that would take a little too long. There's another way we can sort of just speed up the process here. So the first thing we want to do is stretch this cube. We want to find a way to make it look like a rectangle, a rectangular object. So in order to do this, we want to stretch it out in some way. And as I've said before, in the transform, we have different, when you click on the cube, we have different properties that we can also learn and modify. We have a rotation after the position rotation, but we're not trying to rotate anything here. We're trying to stretch, and we can actually stretch things by changing the scaling of our cube. We have an X and Y scale, X, Y, Z scaling, and you can see in which direction that would scale based on the arrow here. So for example, if we change the X scale, we would have, like, I don't know, 10. Look at that. We would have it stretched on that axis, on the x-axis, and that actually is what we want, because it seems to almost perfectly, yeah, it would fit perfectly the entire length of this side of the plane. So that would be a perfect wall for us. So actually, the value is to put 10 for the scale on the x-axis, and you would have a wall made for you. So we just stretch one cube to make it appear as a wall, or some type of barrier for our level. So once that is done, you put 10 on the x value scale of your cube. You would just drag it, or let's see, no, let's do this in a way where we can make sure we do this as precise as possible. So hold Control on your keyboard, and then click on this blue arrow right here, and then drag it to the left, and you see it'll be moving in sort of slow or specific distances, and this will basically align it perfectly with the plane. So while you're moving it, right, you're holding Control on your keyboard, and you're holding the left mouse button to line it up correctly with the side of the plane. If you don't, you would just have a slide. It'll just stop at whatever position you would want, but we don't want that. And if you do mess up, you can always click Control Z at the backwards option in your computer. You just click Control Z, and you can go back to sort of an undo option. So once you have that, we have one wall already. So what we could do is create another cube, change the transform on that to the rotation, and change it to X. But one of the great things about Unity is that you're able to copy and paste items that you've already made, similar to files or anything else you might have used for copy and pasting things. In order to do that, all you have to do is right click, click copy, or you could also use your Control C keybind on your keyboard to do that. But if you want to do it this way, you can click copy and you would just click paste, or Control V as a keybind, and you would have a clone of this, as it says right here, cube 1, because you already have the original name, but it needs to give it a new name. It can't be the same name. So it's in the same spot as the other one, so it doesn't look like it was here. But if you hold Control again and you click this to the right this time, because we want to cover the right side, you will see it actually comes out here. And let me just move a little over here so we can see if it lines up correctly. And there you go. You have two walls, and we just easily just clone something we already modified and designed. And this makes our process of building the levels really easy in Unity, just so we can able to duplicate stuff we don't want to manually input over and over again. This is really convenient. So we want to create two more walls here on the side, and in order to do this, we need to figure out a way to rotate it so it can cover this side, because if we just create another one, we're just sort of gonna have to be lining up here over and over again, and it'll just cover the entire plane. We just want to sort of rotate it to appear on this side. And in order to rotate it, we would like to, let's see, well, first, before we rotate it, we want to sort of have an organization for these cubes, right? Or like our level. So before we go on to adding more walls, go to your hierarchy, right click on the empty space, click create empty, and this will create an empty game object, which you can, once again, go to the inspector. Once you click on it, reset the position. And then this is not something you would use in terms of something visual. It's invisible. There's nothing really about it. That's why it's called empty. It's more of a placeholder. And think of it as a way of creating a set of organization for your files down here. So you have your assets folder that'll just contain everything else in them, but realistically, there's nothing really. Everything's in the assets folder, but it's just sort of a placeholder or header just to keep everything in there. So this is what the game object is going to be used for. There's more things you can use this for, right? But in our case, we're just going to use it as a way to organize our hierarchy view or hierarchy tab, which is something important that I mentioned before. So we can do this by sort of renaming it. You click right click on this object, click rename. For this, we're going to call it level. And this is going to be, this will contain all our objects in our level. So basically, we want to click on our plane, drag it, click and drag, and drop onto level. And look, you have another hierarchy and level drop down of objects within another one, or an object within an object. And like I said, it's just more of a placeholder to keep things organized. You would do the same for these. And to be faster, you can multi-select in this editor. You would hold Control down and select another one. You have two selected. So now when you drag and drop, they both get put into the level. And now you have all three within this organization tab here. So now if you clicked on the little arrow up to close it, it would hide them all. And now you have a sort of a clean hierarchy here. You would like to look at them, just click on it again. All right, now that we have that set up, let's continue with the level design, or building our level here. And we would want to duplicate another cube. So we have this cube right here, right? So we want to sort of rotate this on some axis. So now we're going to be looking at, when we click on it, on the inspector, we want to look at the rotation options we have here on the X, Y, and Z, because we already tried scaling, we tried positioning, we got as much as we can from that, but we sort of need to just turn it around on a 90-degree angle just so it can flip, so we can cover the other ends of the wall. So in order to do this, we need to see which rotation axis, or which axis we would need to rotate this object on for it to work. And in order to do this, we would like to test this out. So let's first duplicate this. So you would copy it, and you would paste it. And the thing is, if you just paste it right out here, it's not going to put it within our hierarchy or within our empty game object here, our placeholders, you might have to add it again, and it'll do that. Another idea is you could just actually paste it on here. Well, it actually did not work this time. I'm assuming this is something they removed before, but ideally it would paste it outside and you would just have to drag it in there, and it would work just fine. You would just make sure to drag it in here, and you would have everything organized. So let's see. We have 2 of them I duplicated, but let's just use this one right here. Well, let's just go one at a time, right? So, no, that was correct. My bad. Yeah, this is the thing. When you get too many of these, it might seem a little confusing. You could rename these two. You can rename these two, which we can do right now. It's optional, but you might get confused at which one you're looking at if they're all like sort of the same name. So this is cube 2, this is cube 3, and yes, so this is cube 1. Yeah, we just don't have to put 1 on there. And the cube 3 is the one we're going to be rotating on. So we look at the inspector on the rotation, and we want to see sort of which axis is going to be rotating on. So let's say we wanted to, we want to rotate 90 degrees, right? So let's try out the x-axis, see what happens. Yeah, so the x-axis, right, is just it's just going to be rotating on itself, sort of just like if it flipped over. Because on that axis, as you can see right here, we can click on this little button up here that says, oh, it should say rotate yes up here. You can sort of see the outline of how things work in this coordinate system and where things will be rotated on. You have like these lines, like a circle sphere. So you click on this and you can see on the red line, it rotates on that axis, on the x-axis, in that way. The y, it rotates it side by side horizontally. And we were going to be using this one. We just realized that we can actually, this is the one we want to move. And the blue, or the z, flips it vertically. So now we know all the rotation sides that we can move game objects on. So we would want to go to the inspector, go to the rotation scale, or not rotation scale, rotation property, and go to the y-axis and click on and input 90. And there we go. We have a rotated game object, rotated wall that we want to fill our level in. So we want to sort of move this around to fit that side. It may be a little too big, and we can shorten it up, but realistically, as long as it covers up that side, we can work with that. It won't cause any extra problems. So hold Control, click on the little blue line on the little blue axis here, and you can line it up. Click on the red one. Make sure you're holding Control while you're doing that, and there you go. You have the wall covered. And like I said, it will probably intersect with the other wall, but like I said, it won't make any difference here. It'll work just fine. So we want to do that again, but this time what we can do is duplicate the one that's already facing that direction, so we don't have to rotate it again. This is the beauty of being able to copy and clone things in Unity, or objects. So you would copy and paste it. I did it with a keybind there. That's why you did not see me right click on it, but you can also do that. And then, yeah, so something I noticed there is that when you do the keybind, it actually remains in the folder or the hierarchy empty game object. So you might want to do that so you don't have to drag and drop it. Just Control C on the object and then Control V. All right, so let's drag this over. And there we go. We have a little arena or level for our player and anyone to play in. We could just sort of, this will be what the game will look like. And this is something we'll change later on. The camera's only showing the side view, right, of our level. We'll make it so it shows the whole thing, but it's placed in the wrong position right now, which we'll adjust soon. So now we have the entire level made. Well, almost. This is the base level. We need to next create the obstacles, and lastly the exit. In terms of just the world design we have here. So, in order to do that, we would first want to, close this level. Well, yes, because this is the base level. We want to create another empty game object. Well, first let's place let's place the actual levels or the obstacles we're gonna make here. So what we could do for this level design, right, the one that I had showed you guys, we want to create these 3 walls right here. If you guys want to make your own level, you can, but I'm going to be going off the one I have designed already. So we want to create these walls. They're about half the size of the main walls for the borders, so we need to adjust the scaling for that so it can be half that size. And that's relatively easy. So let's copy, let's see. It could be any of these. This one right here. Let's copy it and let's close this and paste it out. We don't want it to be in that or on that level anymore because you want to just sort of separate and differentiate the things we have in our level. This will not be part of the, it is part of the level, but we can make a separate folder or organization for it. An empty game object to handle everything in there so we can look at it easier and quicker. So we have it right there, the duplicate or clone. Let's rename it to obstacle 1. And then we would have, like I said, this is optional to rename it. You would just have to recognize and see where these things would be in your level. You don't have to rename it. So we renamed it and we want to make it half or about half. Close to half. Let's just see how it looks like in half. So in order to do this, click on it, go to the properties or in the expector. And in order to do that, last time we adjusted the scaling for the X. So originally it was 1 and it makes it back into a cube, but we want it to be into something a little bit longer. So let's try 5. 5 seems to be about half, and I believe I had went with the value of 4 in case, well, let's see how it looks like right here. Just because we want to have enough space for our player to move around in. So let's hold control, move it. You have this right here. Let's see. There we go. So we have something like that. The player would be put somewhere right here. And we can move it just maybe a little more right there. Might be a little too much. We just want to have enough space where we can place our sphere, which is the player that we're going to be controlling, that can maneuver through this little space here. So it seems to be good, but it might be a little too long. And the thing is, we could just push this back. We have it like that, but or like this. And you can have it like, you can just sort of move it to where you would want it to be. We realistically don't have to change the value. I mean, if you want, you can just lower it down and just make it smaller there, and you know, just adjust it. It really just, you're just messing around with these little settings to sort of just fit into how you would like something. But there's many ways you can do it, and for this, in this case, I'll be putting 4 for the X scale, the X value, and that should be fine. Well, if you need to adjust anything, we'll do it as we go on. So we have that set up. Let's make 3 more of these, one on this side and one on this side. Since we already have this template or prefab sort of set up, which prefab are actually something else we'll not be discussing in this tutorial, but they're actually a certain feature in this editor. So click Control V. You have another one ready. We'll drag it out. We'll move it about over here. It seems to be a little too close there, so we might want to move it a little bit more. That should be enough for our ball to fit through. We want to control and paste it again. And like I said, I'm doing the keybinds with this, so it's a little easier and quicker to do. We want to drag it back over here or right there, and then move it a little bit to the side. And you would have about equal spacing between these two. Just about. It looks correct right there. Right, everything looks in the center. And like I said, we can always adjust these things later. So there we go. We have our obstacle set up, our main level set up. And now we want to organize these obstacles. Here you can rename these to another name to sort of just differentiate them. Obstacle 2, right click, rename. There you go. So now let's create a empty game object as we've done before. And let's rename that to obstacles, plural, and then we hold control, click on each one, and drag them into this empty game object, and there we go. We have our obstacles and main level organized, so we could just close that. And the cool thing is when you click on this, you can actually drag all these at the same time, right? You could drag everything at the same time when you have it. That's one of the other features of creating these empty game objects, because it's a game object on its own, but it sort of combines all the coordinates together to make it, to combine into one. But we won't really be doing that for this scenario. It's just something to note or know about. So we have this set up. Next thing to do is to represent our exit. And we did this in in my example here with a cube. And we'll be adding color to everything soon. We'll do that in the next section. We want to add a cube. That would be our exit. And that's relatively simple. We've done that already. We would just go to 3D object, cube. Click on it. Reset the position at the little dots right here. Or input 0 on each one if you like that better. It'll come up. Make sure it's at the 0.5 height, so it's above the ground of our level. So make sure you go to the cube and input 0.5 in the position. You would want to click Control. Let's drag it in here somewhere, and then we can just input it right here. And there we go. We have our cube ready. And yes, it should fit there just fine. And we'll just be using that for our exit. So right click on the cube, rename it to exit. And we could put this into our level or somewhere else, but since it's a separate object on its own, we could just leave it out there since we'll be doing some other changes to it later. So we'll just leave it on the outside. And there we go. We have our entire level set up. Now we just need to add our player in and see how that works out before we make any changes. Well, before we add a player, let's just give our level some color and life. I almost forgot about that. My bad. So in order to add color, or yeah, because this is a default color. This is a default material or shader. So we want to, you could use this one, but we want to make it just a little bit more unique and bring some life to it. So we want to create some type of color to it, or add some color to it. So in order to do this, we need to create a material. That's a new idea in this editor. So in order to create a material, let's just first take a look at our project view down here, right? We want to start using this to make our materials to organize, because these materials are something we're going to have to make before we even add them onto here. So go on your assets, click on your assets folder. You can right click on it or on this space right here. You right click and you're presented with a bunch of options. Click on the first one, it says create. Look for where it says folder, should be the first option. Click folder. Call this folder materials. And there we go, we have our own new folder. And you can go out of it by just clicking back outside. So now we have a area or a space in our project view to just work on the materials and not have anything else in the way. So let's create a material. And how do you do that? Right click on this empty space here. It's empty. Create, and there's an option that says material right here. And now we're going to create our texture for our game object. So the first one we'll be making is just the ground and the walls, which was a sort of cyan or light blue color. It could be anything you would like, but we'll try to mimic that again. So let's just create this level, or level. We'll call it level because this will be the same color that we use for the level objects. You can give any name you like, just something you would want to recognize easier. So in order to change the color on this, right, we have to go to, we would click on it again, similar to it being a game object, right? You click on it and there's properties on the inspector view over here. And we won't really be looking at the majority of these. It'll just be really just one, which would be this little pointer pen here and this little white box. If you click on it, you open it, it presents you with a color palette where you can modify the colors on this material. And like I said, let's choose a sort of, you just click anywhere you would like to change the color. The little white circle indicates that. And once you click on main color here, you can click this little black circle, which will change the values, right? Change the values of your material. And you can also input down here if you want to just search up or put a specific color value, or in hexadecimal version. But we'll just be doing it this way, where it's a little easier just to sort of estimate here. So we'll have something like that. That looks a little nicer. So now we have this little light dark blue color. And then, yeah, so you just click on this, open color palette, click on the circle where you would like to start from your base color, and then move the black circle around to just sort of move around the shading or levels of your brightness or darkness of your color. and you just click exit and it's already modified. And now all we have to do, it's just as simple as clicking on this and dragging it onto anything you would like. And you can see before you even let it go, it's going to show that's going to modify it. So we're going to put this on the ground, let it go. And there we go. We have our ground being blue or light blue. And then we can do this as many times as we like. And we would have this here. And it's going to seem a little glitched or buggy here for some reason. It seems to be having trouble. Oh, okay. Well, the reason for this is because we have, as you can see right here, it stopped looking a little weird. We have it intersecting with these other rectangles. This is what I was saying, that we could have made it a little bit shorter and smaller to account for this, but we'll see right now. If we both make these two walls the same color, then this little visual appearance or glitch should not be happening. So let's try that out. And there we go. We'll just have to do this for all walls. And you have everything working just fine. It looks really nice. So now we have our base level colored. So let's give some color to our obstacles and exit. So we'll repeat the process. We could duplicate again, but you would want to make a new name every time, and you could rename it manually, but it's really not that big of a deal to just click create and, go to material, and there you go. It's the same thing. I would just recommend you just do it that way, so you don't have to sort of just find a way to rename things. Because it's not really moving it around in an editor, right, as a hierarchy. This is more just placing it in there inside the scene view. Let's call this obstacle. And yes, you could capitalize it if you like. We click on this little rectangular color, white color, next to the little pen up here in the inspector. Again, color palette. I believe I made these purplish for some reason when I first prototyped this game. They don't have to be. It can be whatever color you like, but I'll make them purple again. So move it to move the white circle to the purple, and then sometimes it'll be black or white, but just you would move it wherever you like in this little square to find the shade you would like. Click X, and then drag and drop into each obstacle, and there you go. You have the obstacles colored. We just need the exit now. Create another material, and then we'll call this exit. So make sure you call these exit. You can, like I said, name them whatever you like, just to signify what we're doing here, or what game object is being, which material is being applied on which game object. Click again on the color palette. I made this yellow, I believe, some type of dark yellowish color. Yes, so you have it like that. Drag and drop it, and there you go. We have a, well, actually, you can also edit the color again once you put it in, and it will actually modify it already for you, because it's already added to that game object. Just click on it, go again to the color palette, and as you can see, if you move it, it's already modifying it while it's already placed in there. So, you would do that. I might just make it like that, just to pop out a little bit more at the max. And there we go. So that's a good little convenient. If you already have it made and you re-added it, you can just edit it already directly, and it will just modify the color value when it's already in the game. So we have our level made. It's a little different from the example I showed you, just because I didn't get the color RGB. The RGB value is exactly the same, but I mean, realistically, you can always change it whenever you like. We just want to differentiate the objects here, and that's the main idea. So now that we created our materials, and we have a materials folder for that, we want to adjust the camera, because as you can see, when we go to the game view, right, our camera's in there. We still see one side of the view of the actual world or level. That's not really what we want here. It's not going to be some 2D game. We're in a 3D space here, so we want to make sure we can see everything. So our idea in the camera view is going to be a top-down view, where we're going to look as if we're playing it like this, or top-down. So this is how our game view would look like in the game. When we actually play it, we would control it like this with the ball starting here, sort of like a ping pong game, and then you would just move it around like this. But we'll be looking at it from the top-down view. That's what top-down is. There's other many camera views that you can study, but for this case, we'll be doing top-down. In order to do that, let's adjust the game object camera that was already here in the main camera. Click on it, and look at the inspector properties. What do we have here? All right, so we have the -10 for our position. So we just sort of need to move the camera into its correct position and rotate it on some axis so we can view it, right? So in order to do this, we want to, let's see, we want to move it higher, obviously, because we want it higher than the actual level. It seems it's facing that way on that side, which is why it's showing that side of the wall, right, in this preview. We want to move it higher. So let's see, let's move it upwards. You can hold control on these two. What would be a good height? My notes say we went over to something like 11, which it's just a rough estimate, as long as it shows everything in the level. And yeah, so we would have that, and the position on the z-axis is modified. So let's move that to 0. It was on -10. You might want to move it to 0. So make sure that's reset. So you have your x 0 for your position, and your 11 for your y position being 11, and your z position being 0. And then we would have to rotate it because it's facing in the empty space. There's nothing shown. And how would we do this? Well, we want to, of course, look again on the rotation axis right here. What would be the coordinate or the axis to rotate this on? And this would be, once again, the x-axis. We rotate it like this, right? 90 degrees, you can see the game right there. So we'll be doing that. So let's do this real quick and see if we can modify it. So let's rotate the x-axis to 90 degrees. As you can see in the game view now, we can actually see our game. But it's not really in the orientation as what I have shown, right? It's a little weird. It's sort of like flipped on another side. If we look back again, we want to sort of just flip it one more time on that axis. So in order to do that, we need to change the rotation value again. And for that, we would modify the z to 90. So there we go. So we had flipped it vertically up and down, but we have to move it from side to side. So that was the right here, this blue, the z scale, right, or the z rotation. So as you can see, we're moving it here. There we go. As we move it, you can see it. That's how it moves the horizontal axis right there. So yeah, it just really depends on the orientation of your object, where you have to sort of, you click on this little option right here, move rotate, and it'll just, you click on the way you want to rotate, right? Or I clicked exit by accident on the main camera. And then you can see on what axis you would need to rotate to account for this, in case you forget. All right, so now we look at the game view. There we go. We can actually see our game correctly now. It's just as the preview we're trying to, or example we're going to mimic or recreate. All right, so now we have our view set up, and now we just need to add the player that we're going to control, which is the sphere. So in order to do that, let's create a sphere object. Right click on your hierarchy, 3D object, sphere. And we're presented with a sphere. Well, not quite, because it's under the level again. So click on the sphere, go to inspector, click on transform, click this little 3-dot option, reset position, and you have it up. And we might have to sort of adjust this sphere. It might be a little too big actually for our level. We could actually downscale it just a little bit. Let's move it up to 0.5 so we can have it above the ground. There we go. It looks a little too big. It might not fit between our walls here. So to account for this, we could change the size of our walls and our level, but that would be a little too much adjustments for what we already have. So we could just make the ball smaller. And in order to do that, we can change the scale again. So you would have to mess around with this, right? You can just sort of move the values here. You can just drag and see. But you would have to really be careful of that because it might just look really weird. So I just want to go with like bigger value decrements or increments. So in our case, we want to, if you're going to change the scale of something, you want to change it on all scales or all axes. So we can just have the same one at the end. Now look at that. You change X, Y, and Z to 0.5 from the original one being 1, and you create half of that size downscaled. So you have a little ball here that will definitely should fit in between these objects, but we're gonna have to rescale the y value because you can see it's above the ground. This was originally when it was bigger, so we're gonna have to adjust that here. Let's see. 1 second. Okay, so we have our sphere here modified, and the sphere needs to be sort of moved lower again, or down to be closer to the ground. And we can do this by modifying the y value. It was originally at 0.5, but we wanted to adjust it to to touch the ground. So if you move it down, right, you have a, let's see, we can put it at 0. No, not 0. Oh my gosh, my bad. All right, so, well, actually, the idea for a sphere, right, is going to be something where we can control it with gravity, or gravity will be affecting the sphere. It's the player. So first, we want to move the sphere in the position we want it to start from. So this would be right here. And for this value, you can just sort of just move it around. You don't have to hold control and snap it anywhere. Just somewhere there. And we can leave it in the air, actually, because, like I said, we're going to have our sphere be affected by gravity, so when the game starts, the sphere will just fall down and collide with the ground, and it would just be in place. So we don't have to actually set it on the ground, but just to show the gravity when the game starts, it'll be pretty cool to just have it floating in the air already, because that's the physics we'll be applying for it, or apply onto it. Right now, if we click play, right, it's not going to do anything. It's just going to, you may not see it too well here, but it's actually in the air and nothing's happening. There's no physics on it. So yeah, we'll do that next, but that's what we have right now. Make sure you can downscale it about halfway, 0.5 on your scales, and that should be the design for our character. Well, actually, let's give it a material. So go to your materials folder, right click, create a new material, name it player, go to the color palette. I believe I gave this on red, so I want to give it a red color. And there we go, we have a red color here. So now we have everything signified, and then let's see. Let's rename our game object on the hierarchy to player. So now we can have that differentiated from everything else, separate. Okay, so now we have our entire layout of our design, or of our level done. This is bring everything to life. This is sort of, we want to make our obstacles reset our player when we touch them, and we want our player to move with our keyboard controls. We want to beat the game and reset the game potentially when we reach that golden block, which is our exit, or cube, I should say. So this leads into the next section of game development in Unity, or creating a game in Unity, and that's coding. So we're going to be coding the physics, but there's actually one last thing we can do before we get to that, and that is when you click on the player, you go to the inspector. Like I said, anything you see here that are properties, these are properties within something called components. Mesh renderer, transform, sphere, sphere collider, these are all components, but within these components you have properties, and that's what we've been changing so far. So above that is the term for that is components of each one, because you can close one, right? And you can see each component. So we actually want to add a component this time around to add physics that's already pre-made with the engine. And this is going to be called rigid body. So you would click on add component. In the search bar, you just type in rigid, a part of the actual component, and this will show right here 2 of them. We're going to click on the one that does not have 2D because that's the 3D one by default. Click on the non-2D one. And now we just literally added all physics into this game object, including gravity and everything. It says right here you can use gravity or not. You can uncheck this or check this. So now when we click play, you should be able to see it fall. There you go, it fell just really quickly. And yes, there we have gravity automatically applied without any coding, but we still need we want to make it move in the first of all. So we will need to change some things later on. So in order to do this, let's see, we're gonna have to change some settings on here. So in this property, click under constraints. We're gonna have some problems in the future where we would move the ball, and it would be continuously moving even after you would let go of controlling it. We don't want that to be slider and being a problem. That's not part of the game design here. We want the ball to stop after we let go of controlling it. So we would click on the X for freeze rotation and the Z. This is under the freeze rotation, not the position, the rotation. Yes, because it would prevent it from rotating after you already have stopped moving it. So make sure the X and Z axis are checked for freezing, and we should be done with the rigid body settings here. So now let's move on to our coding. In order to do that, let's create a folder again. Go to your assets, right click, create folder, and let's call this scripts. They're going to be called scripts. The idea of our programming files are going to be called scripts. That's what they're called in Unity, and that's their term. So we have a folder named scripts. Go inside that folder, right click again, and we're going to create a C# scripts, the second option. And now we can give this a name. The first thing we're going to be creating is our player. So we could call it player again. I'm going to call it player controller because that's what it's going to do. It's going to control the player. We're going to give it controls and life. So call it. You could capitalize names. The only thing you have to know is that when you create a coding file or a programming file, there should be no spaces. The spaces are not allowed. Show spaces here, but that's just the layout here. But when you actually type it in, do not include spaces. You could capitalize objects, just no spaces and no special characters. That's just part of the syntax. So when you make a file, just some name like this, you can use this name exactly. Player controller, right? So once you have this made, we want to let's learn how to add it to the player before we even add any code. So there's two ways you can do this. You can click on the player, click add component, search up player controller, and look, it's right here. You just click on it and it would add it onto here. But a faster way is you would just click on the player and drag and drop it onto there. And look, if you look on the inspector now, it's right here. Player controller script. And that's way more faster and convenient than having to search for it on this add component option. These little sort of shortcuts make things really convenient when developing games in this editor. So now we have it added. The point of adding the script onto here is so that whatever changes or code we add onto the script, it will affect this game object specifically only and nothing else. So the way we can open this is by double clicking on the actual script. Make sure you double click. It'll ask you what you would like to open this with, and you should have Visual Studio installed because it was part of the process of when you install in the editor. When you clicked on the bundle that I mentioned earlier, you should have this software be installed already as well. You click OK when you're prompted with that, and it would be opening the background. It might not always appear right away in front of you. You might want to check your applications in the bottom of your screen, your task manager or taskbar, and it should be there. So for example, it popped up on my other monitor, so we want to show it right here. So here we go. We're in an editor called Visual Studio, and we have some code here being presented to us. So now we want to figure out what all this means, or at least this template, because this is a template of pre-generated code. Nothing here really does anything to our game object or to our sphere. We're going to be adding those things. So let's start off by discussing some of the things that are shown here. So the first thing we want to learn is what this public class player controller mono behavior is talking about. Basically, it's saying that we're going to use our name right here. So this is our name of our file that we just made, our scripts file. Player controller, that's it. That's literally all it is, just the name. That's where it's getting it from. Class, and then we have our name of our file. So basically, this is just signifying that we have a specific set of code dedicated to this file name or this file, and it's going to separate it into a class. There is more behind this class term. It's part of object-oriented programming, but for right now, basically, you just have to understand that it sort of just organizes our code in a given space for something specific we're going to use it for. And the public term right here just basically allows it it allows this class, right, or this script to be accessible from other scripts we might make. We might want to use the code in this script in another one. You can actually do that. And you can also modify values within the editor if you make it public. So there's certain things like this that will, it just sort of makes accessibility easier for us when creating scripts. So that's what these three terms basically mean. And this mono behavior is part of the syntax in C#, where we're going to be using functions and methods from another script class similar to this one called mono behavior. We're going to be referencing and getting stuff from there. So if we didn't have this, we would have errors, and anytime we would call any of those functions, it just wouldn't recognize it because this is sort of just a way to call them. All right, so the options up here, we have see. Yeah, so we have these options up here. Using system.collection, using system.collection.generic, using engine. So basically, these are imports. These are just ways that they're similar to this extension right here of model behavior, where you would want to import certain libraries. These are all libraries that will also contain functions and methods that we would potentially want to call or use in our code. So these come already pre-generated and contain most of them. If there's something specific, you would have to type your own, which we will be showing that later, or I will be showing you guys that later. But that's how they are. They're just more additions and things we can use for our code. And the syntax is using, and you would put the actual library path. All right, so the actual first method that's shown here is start, void start. So this is a method, or I was talking about earlier, a method is just a function that will do something. Inside of it, you would type the code and it would do something. In this case, we have a pre-built one that the game engine already has called start. Start is called before the first frame update. So the idea of what that means, right, or like what this is talking about, is basically whenever we boot up our game or load it and we run it, right, the first initial state of when it starts, anything that you would want to happen as soon as it starts, you would write the code for that in here. It would only run once. It would not constantly be running. Anything you put in here, so like if you want something to appear right away, like a picture or something to spawn into your game, a zombie or whatever you would want, and it only happened at the beginning of the game when you would start it, you would include it in this method, since this is the first method that will be called before any other method after it. There is actually a few before this one that are more specific to certain beginning functions, but this is the more generic and common one. So you would want to put whatever you would want to appear first in your game in this method. And it's also a way to initialize variables and stuff, because like I said, you want to create your value. You wouldn't want everything to be filled out and created at the initial state. That's what the start method does. Just creates everything at the beginning. And then our update method continues that. So basically it constantly says update is called once per frame. So basically these terms of frames, right? I should probably discuss that a little bit more, because it's sort of its own concept. And update is going to be something that's constantly running. The update method is something that anything you put into it, it would be constantly running in the background when your game is running. So not just in the beginning like the start method, always running repeatedly. So, but just to explain, elaborate a little bit more on frame rate, or frames, as it's putting here in the default explanation that comes with the template. Frame rate is the frequency or rate at which a given frame will consecutively appear on some given display. This means that, for example, frame rate is not just using games. It's realistically an image or a graphic presented on your computer or your device, and this is shown on some type of speed or rate on your system or your device. Each computer or device you use can do this faster than others. So any image that appears on your device that's displayed is being calculated in the background. You just don't see these calculations happening. This is already done inside the actual device. And basically what frame rate does is it determines the performance of our game. It will determine the performance of our game, and realistically anything you use on your computer, frame rate determines the performance of how it runs. And you would know this by certain games or things you run. They may run slow or bad. They may not seem well. That's because their frame rate is really low. When you have high frame rate, that means it's running really well. You want to aim for a higher frame rate rather than a lower frame rate. So frame rate is all about performance, and it's all about calculating what image is being displayed in front of you. And for a game, it's really important, because most of the time we're only displaying images, unless it's a text-based game, and we're aiming for an image one here for 3D objects. So we definitely need to account for frame rate. Not in a way that's very difficult. It's just more of considering the fact that it's relevant here. But we shouldn't worry about any optimization problems. It should run just fine once we're done. All right, so like I said, the update method does this, where it would run once per frame. So it's constantly running in the background, checking it, and start only calculates it once. So there is one more method called fix update that we'll be discussing later, but I would like just to make note of it. You would just type in void, and you would type in fix update, right? So something like this, and then you would have that. But I won't be typing this just yet because we're not typing the actual code. I'm just explaining the template. The point of this one, just to go over right now, I'll go over again later, is just the fact that this one is running on a different calculation than the update one. It does the same thing in terms of, running certain code over and over again to check it throughout the game when it's running. But the main difference is the fact that this fixed update can run multiple times in one frame, while the update only runs once. So basically, you would use fixed update, for example, when you're adding physics to your game. Physics has its own calculation and time being calculated on its own aside from frame rate. So you want to account for that when designing a game that will involve a lot of physics or any physics at all. And specifically, we need this because our rigid body that we added earlier in our editor, right? The player, and you see rigid body. This is a physics component. We want to make sure that any calculations we do for that component is done within this method so that it's able to account for the physics calculations and the frame rate calculations together. If you put it in here, it will not do both. It would just rely on the frame rate, which it wouldn't be having the physics calculations being accounted into the formula, right? Which will allow for bad performance. So we want to make sure that we use a fix update whenever we are dealing with physics built in our game, whether it be our own physics code or pre-made components such as rigid body. You would just want to have a smoother performance, and we would do that by using this method right here. So those are the main ideas in this template that you would need to know to further continue coding. So let's actually begin coding. So the first thing we want to do is go up here, click enter, and we want to first type in these few lines that should be presented to you on the written document as well. But we want to, I'll be going over them as well. So the first one is private rigid body RB. So the idea of this is we have a variable. So these are going to be called variables, right? We're creating our variables. Variables are just values we can use and change within our code. They hold something special or some value to them. And this first part right here, or this ending part, is called RB. This is the name of your variable. You can change it to whatever you like. It's just the name I gave it, RB. The semicolon is just sort of like think of it as like a period to a sentence. It's just a syntax to closing a variable statement. So that's what these two things mean. Rigid body is a type of a variable we're creating. We're creating a rigid body variable type, which means anything we use with this variable will be used to calculate or apply physics on in whatever game object we use it on, right? We're going to mess around with the physics. That's why we're using this type rigid body. So your type of variable goes in the middle before the name. Private is the accessibility of your variable, right? You want it to be available to only this class or to multiple classes. In this case, we only need to modify it for this class because it's going to be only for our player. So it needs to remain private, or it should remain private, because we won't really be changing anything except only within the code. It's not the same thing as the class being public, because we do want to access the class from somewhere else. So we would have it private in this case. So there's private and public. These are the two more common ones you'll be using. So you have your accessor modifier, so it's called your variable type, your data type, and then the actual name, and then the syntax to close it off. That's the basics of creating a variable. So let's create another one. Public. We want it public so we can access it within our editor or any other class. We're going to call it speed. We're going to make it equal to a preset value, which would be 800 f, and f stands for float. It's just another way of saying that this is a float variable. This is a default one in the, or already made one in the C# language. This is one that's made within our game engine. This is just saying that's a single precision floating point number, just a long decimal. It can be a long decimal number, only decimals. Even if it's if you put just a whole number, it would just be 1.0 if you put 1, or 2, 2.0. In this case, it would be 800.0. So yes, we want to have this type of variables just in case we want to modify certain speed values. You would want to see the full thing. So now we have our variable set up, and that's what they do. We just have them. They don't do anything. They don't make any changes in our code yet or our character. They're just preset values that we want to use for later. So now let's see. We initialize. So this is called initialization when you equal it to something already here. This one's not initialized. This is pre-initialized. It's just set here. but we want to make it equal to something as well. But we want to do this in the start method because we want to set our physics engine or our component to only be working as soon as the game starts, right? This is the proper way of setting a component that needs to be set in the beginning, and not constantly updated or appear, right? You would put it in the start method. So we have this RB, our physics variable, equal to get component rigid body, and this get component function here just basically just says we're gonna get the component on our player. So the script is on our player object, right? But it wants to get the rigid body component, but we want to get a specific component from here. We're gonna access the rigid body, and that's what it means. We're getting the rigid body component, so we can modify stuff within that component. So now RB will contain those properties that we can use. So we won't be using update. Let's delete it. Alright guys, so let's continue with the fixed update method. I had a few problems with the recording and I had to sort of redo this part that I was about to continue with in the fixed update method. So let's begin or let's continue I should say, by first fixing this one typo I put here. This is supposed to be a capital F actually. There we go. As you can see, you might have gotten an error before if you left it as a lowercase f when I was explaining it previously. That was just a typo of mine. It's supposed to be, for the syntax, it's a capital F, and that's the syntax of the fix update method. So make sure you do that, otherwise you'll encounter some problems. And the reason why I deleted the update method and we're using the fix update method is because, as I've explained already what the update method and fix update method do, we're going to be creating our physics and adding physics to our player. So whenever we're using physics from the rigid body component, right, I already showed what the rigid body component was. We want to apply those to our player, and we want to have our frame rate be smooth and just let the game engine sort of calculate our frame rate based on the physics frame rate per second calculations. There's a sort of different calculations being done here, and I've just gave the simple idea of how it works is just when we use fixed update, we want to just have it so anything we have in the fixed update it's only used for physics code, and for the update method it can be anything else you want to normally or have a routine of checking within your game to constantly be running. But in this case, we want to add physics to our character, and we're going to do this within the fixed update method because that's what it specializes in for our game. Alright, so the first line of code we're going to begin with is we're going to create a variable. It's going to be a type float, which is going to be a floating point value or decimal. We're going to call this variable move horizontal, as right here. I'm going to show. We're going to make it equal to input.getAxis. Parentheses within, these are the parameters of this getAxis method. I'll explain this right now a little bit more. We're going to type in here horizontal, and we're going to end it off, as I've said before, we end off our creation of our variables with a semicolon at the end, so similar to a period at the end of a sentence, just part of the syntax. And so for this variable, or this line of code right here, this basically means, my bad, let me go back. Creating a variable called move horizontal. It's going to be a type float, which is a decimal point, right? A decimal value. We're initializing it with this equal sign, as we've done up here with the speed. Initialize it to 800. We're initializing it to a method call right here. Input is a class similar to player controller, right? Input comes in from one of these libraries up here. It's being called. You won't see it being called. There's no input class you can see here. It's just sort of loaded within the libraries and the imports we made on the top. So we call a class called input, and we call a method from that class called getAxis. And what this method does is it shows right here, it returns the value of the virtual axis identified by the axis name. And the axis name we're using is horizontal. Inside these parentheses are the parameters. And the parameters show that it's going to be a, as it says right here, string axis name. And we haven't gone through this yet, but there is another type similar to float, integer, and double, decimal, integer number. There's another one called string, which is just basically characters, words, letters that you can make for a variable. And this one we have to, as it says right here, string, we have to put in a word as the parameter. and that's why we put horizontal. You put quotations, beginning and closing, and you type in a word. And in this case, you want to type in horizontal because what horizontal does is it allows us to move the player left and right. So the keys that we were using in the scene view, which were A and D to move left and right, we're going to be using those to control our player left and right within our game, right? We want them to be able to move the ball in all directions, left, right, up, and down. So this line of code basically is going to save a variable that would have our left and right inputs being taken. So whenever we press A or D, those values are stored within this variable that we'll use to calculate later in the formula. So now we'll do something very similar, but for the vertical axis, the W and S on our keyboard, or up and down arrow. So move vertical, equal that to the same thing, very similar. So now you understand the concept of get axis, and you could guess what we're going to put in here, vertical. So now this line of code will get the vertical axis or the vertical inputs on their keyboard. And these are already preset within the Unity engine if you're wondering how it's doing that. It's already within the Unity engine, which you can actually change on your own what horizontal and vertical means. You can put your own keys. I would go more into depth with that, but for right now we're just trying to, in this project we're just trying to get this working here, and that would just be more on the side of research for you to go look at if you would like to mess around with the get axis values they have in the engine, because you could actually modify them. But for the default ones, we're using WASD and the arrow keys, up, down, left, right. So vertical gets up, down, and WS. Alright, so we'll then move on to, so now we have both our left and right and up and down variable calculations or inputs. So now we'll create a vector, and I'll explain exactly what a vector is right now. Okay, a vector variable. So the type of the variable is called vector3. It's a vector. We'll initialize it to new vector3. Inside the parameters, we're going to move in our horizontal variable. We're going to give the y component 0 because we're not planning on moving the player up and down. And move vertical and close it. Alright, so for this line of code, we're creating a variable called movement. It's going to be a type vector3, a vector. We're initializing it to new vector3. The reason why there's a new here is because this is a object or class that we're creating a instantiation of. This is more closely related to object-oriented programming in C# or in any language. You would have to do some more side research on understanding this, but the main idea is that we're creating a class object here, but that's called the class would be vector3, right? And this would be because we're going to be modifying values as we're using this variable. And within this class, we have 3 parameters. Move horizontal, the one we made. This controls our left and right movement. We have our y value. See right here it says flow x, y, and z. So this is our left and right for our character's movement. This is our up and down. If we were to, like, let's say jump or fly, we're not doing that, so we're going to leave it at 0. We're going to be on the ground at all times. And the vertical is forward and backward, which is from this line right here. So these values that we're getting are from the get axis, and they're saved into these variables, and we're going to use these variables in a vector variable, or we're going to initialize it into a vector. So now we just created a vector, and let me go more into depth on what a vector is so you guys get a better understanding of what we're going to do here next. So basically, the reason it says vector3 is because we're in a 3-dimensional space. Our game is 3D, right? So basically what this does is it sort of creates like a line, invisible line within our game. So basically what a 3D vector is, it's a line segment that's in some given 3-dimensional space that will move from one point to another. Basically what that means is that you can have an arrow, right, or just a long line of something, and then from the beginning, from where it started, sort of like if you were drawing a pencil from somewhere to the end, which if you were drawing an arrow on a piece of paper, then that would be a 2D vector, right? If you draw an arrow from one point to another for however long you want it to be, right, that's a vector, because a vector has a magnitude and direction. So you want to have a point to go somewhere in some direction, and the magnitude at which it would be going at that direction. So for a 2D vector, if you want to sort of visualize it, you would just draw an arrow on your piece of paper, and that would represent your 2D vector. Just think of it as in for 3D, if you were to get one of those get an arrow that's 3D in real life and just have it there in front of you. Um, and that would be a 3D vector. It's just think of it as an arrow or a sort of long distance of some given line in the air, or it's invisible, right? And this is what we use to track movement direction in a three-dimensional space. And three-dimensional spaces have an x, y, z coordinates, so that's why vector 3 is a three-dimensional vector. We have a three-coordinate plane here. So that's what a vector is, right? We want to move our sphere in any direction, and we want to just modify the x and z values, which is why we're only using move horizontal for the x and move vertical for the z. Yeah, so we won't be modifying the y value because we're not going to be moving up and down. All right, so that's the basics of what a vector is, right? Just some line in some direction, and we're going to be moving that line right now. So right now, with the current code, we wouldn't be able to do anything with the player yet. Nothing's happening. We just created some variables that would track our inputs, our input values, and we created a vector that will hold those input values so we can move that line or arrow around for our player to follow. And this next line of code, we'll be doing rb.add force. You could imagine what this will do next for our character. Times speed times time dot delta time. And now this will be the last line of code we'll be adding to our player controller class. So what this does is we first see right here RB. This is our rigid body variable. Our rigid body variable is of class type rigid body, or RB is of class type rigid body, which is its own class again, similar to ours right here. It has a bunch of methods. So, you know, methods as in start and fix update that hold code within them. Add force is one of those. And once again, we have parameters you have to put in. We have a vector 3 to put in. Now the thing is, there's multiple versions of these methods, and a lot of them can have different parameter requirements. The most basic one is just putting in a vector. So realistically, if you wanted just put in this in here, this vector, we could do that. It just would move at very, very slow speeds, and you wouldn't notice anything. But we want to modify that. So we're going to put in our vector in this method called add force, right? The whole point of this method it's what the name of the method says, to give force to our player so we can actually move the player, right? So we have our movement variable that tracks our left and right and forward and backward movement. We're going to times that with our speed variable that we made above, 800, so we can have some faster movement. And we're going to times that with time.delta time. And this is the last new concept I'll be talking about in this class, or in this player controller class. And the idea with time.delta time, right, is that we want to, it kind of goes back to the whole point of adding smooth gameplay and having a smooth game with good frame rate. So the thing is, what time.delta time does is that it calculates the amount of time between the previous frame to the current one. So basically, this creates a new value called time that we can use to keep a constant value between moving objects within our game. So to make it a little bit sound more simpler, there's just this sort of mathematical calculation that, as I've explained earlier, you have frames constantly being tracked, right? In the update method, there's a frame going once every update in the update method, but in the fix update, there's multiple frames happening. So we want to sort of keep a constant frame rate. We want to keep a constant frame rate value whenever we're doing something in our game. So we want to, and we can do this by calculating the time from our last frame to the current one we're on. And this time value that we calculated from doing this, we will use it as a factor in our physics code when applying force to our player, as shown right here. We're having our time.delta time variable. This is the factor that will make sure that in whatever computer or device you're running on that may be running slow or quick, because nowadays people have different levels of, you know, what type of computer might be better than others. Some run faster, some run slower. This will basically make sure that on whatever machine you're running the game on, it will account for how well it's able to process and process frames, and you're basically just have your game run well or not. This will make sure that it runs at the same level as any other computer would. And you would have to include this with whatever force you're applying to your player or with anything else in the game. Whenever you use add force or some other physics method. So we're gonna use it with our movement tracking, our speed, and then we'll add that in there. So the idea is we just want to make sure nothing weird happens. We want to have every device, anyone that's playing this game, we want it to just run well and work on every device. And we do this by just calculating the time between 2 frames, and it just goes in with our code of our physics, because our physics has its own frame rate and we want to account for that. So that'll be basically it for our player controller. This is all the code we'll be having. All right, so what we want to do is Control S to save. Once you save, you should see the little asterisk will be gone. You can also go up here in File and click Save right here, but I would just say Control S is just a lot easier. So we'll go back to our Unity editor, and as we do this, it automatically should load in our code that we just wrote, so we can use it. Now, let's go to the player. We already added the script onto there. And as you can see, we have our player controller script here that we added. And now we have a speed value variable this is the variable we made earlier. The speed equals 800F, or float. My bad. Yeah, so we can modify this value anytime we want in the editor, and we don't actually have to go back to the code and change it. If we feel like it's too slow or too fast, we can just do it right here with the convenience of just typing it without having to actually modify or hard code what we already made. So now we have the code on there, so let's just try it out. Click play. And now, when we hit the W key, we should move forward. When we hit the S key, we should move backward. So the W and S key, this is the move vertical part of the variable, right? That we just made in the code. And if we hit the A key, we should move to the left. D key to the right. And that's the move horizontal variable we're calculating. And these directions that we're moving in is the vector that we created. And the force that's being applied is part of the add a force method that we added. Now, if you were to remove that time delta time factor, you would notice that certain things would not be running or looking too well, that you may have some problems with the speed. You're gonna have to definitely modify the speed. You'll understand if you were just to take it off. It'd just be a little weird. But this is how it's gonna be looking like right now. So we would just maneuver around the level as shown below, or in front of me actually. So the idea is we want to reach this exit right here. And these purple walls are the obstacles we'll have to maneuver around. So when we touch them, we should die and the game should reset. If we make it across the entire level without touching them, we should win by touching this yellow block here. And that would be our exit to restart or exit the game. Alright, so we got our player moving. Great. Like I said, when the game is running, right, it's on blue right here, it's on the game tab, you can modify this value. Let's say we wanted to be at 900. Go back to the game. You would notice really quickly that the value did change after all by a lot. And you can change it whenever you like. The only thing is that whenever you change it while the game is running, when you turn it off, it'll go back to the default level you had. So it's really good that if you want to really just while running the game, you want to just test something real quick, you just change the value. And if you want to keep it at that same value every time, we'll change it when it's already when you have stopped running the game. You just go back to the player and you would change it then, and it will stay as that. Alright, so we want to work on making these purple obstacles here, or these walls we made earlier, being able to kill us or reset the game. So in order to do that, let's go to our scripts folder. We're already in there. Right click, create C# script. Let's call this obstacles. There we go. Alright, wait for the Unity to sort of just load that into the project. Alright, so now what we want to do is to make sure, go to your hierarchy, go to the obstacles object. It might be closed. Click on the little arrow to drop down the other obstacles. Because remember, this is an empty game object that's sort of a folder holding in all our other ones in it. So we have these three right here. Let's go to each one, and as we've done before, let's drag our scripts onto each one. So as you see, once you successfully dragged it, or you want to check if you successfully dragged it in and placed it in as a component, you look on the obstacle and you look down over here, it will show it's been added. Unlike the other ones, we haven't added those. It's not there. So we'll go to 2, drag it, it's added. 3, drag it, it's added. We want to make sure it's on each and every one of them so that every single one of them can hurt us or kill us to reset the game. Alright, so now that we have added each one last thing before we start modifying the code is that for each one again, since the idea is whenever we hit one of these walls, we want our player to sort of just reset or have a trigger. So you want something to trigger whenever you hit these walls, whether it be a victory screen, a death screen, a restart state, anything that you want to happen, you need to have some sort of trigger state. And there is that already in this game engine or in the editor that you can see right here. When you click on the game object, you look at the inspector, you see right here under under the box collider component, there's an is trigger checkbox. It's not checked right now, but we want to check this. Why? Because now whenever we would hit the block, we'll be able to pass through it, or yes, we'll be able to pass through it, but we're not going to want to pass through when we actually play the game. We just want, as soon as we touch it or collide with it, we just immediately restart. But that's the idea with is trigger. Just sort of makes you just sort of go through these objects right here, and whenever you go through them, you can have a check. If you go through them, something happens. So I believe if you were to test it right now, right? If you clicked on play and you went through them, as you can see, we could actually go through through our obstacles, and this is not what we want, right? We want to, as soon as we touch it, we just restart. But the idea is now that we made it able to sort of just test whenever we do go into them or run into them, we can just restart the game immediately. All right, and the way it'll check if it restarts, right, is if right here on the edit collider, if you click on edit collider on the box collider component right on top of this trigger, and you look in closely, there's a hitbox or some type of collider box that checks that if you were to touch this box, something could happen if you coded that in. As of right now, nothing's happening because we don't have anything coded in, but that's what we're going to do next. Alright, so you can deselect it by clicking it again. And let's double click our obstacle script folder so we can open it up. And the convenient thing is that it'll probably leave the other one open for you, so you can just switch back and edit the other coda if you wanted to, or the other file. Alright, so we need to first import some new things in our project. So we're gonna have one new import. On the top, we're gonna be adding the using Unity engine dot scene management, and the scene management library is basically gonna allow us to modify our scene or do stuff with our scene. And our scene, if you forgot, is what we're looking at or making our game in right now. The scene. We have a folder called scenes. So basically, this is your game world. Each of these are your game worlds or levels that you're making. Just think of scenes as levels in your game. They're just what you're going to be modifying and piecing together to make your game. So that's what a scene is, just what you've been working in. And we want to basically reload the scene or restart the scene whenever we die, right? Because we want to restart the game. That would be the same thing as restarting the game. And the interesting thing is we're not going to actually be using the default methods that are in the template as we used before. All we have to do is just check whether our player runs into them. And there's a method for this called private void on trigger. Enter. And now what we have here is a method called on trigger enter. The parameters are collider other, or it's a variable called other, and its type is collider. And it's a method. The void basically means it won't be returning any value, and it's a private type private. Realistically, this doesn't really matter. You won't need to modify or anything. You can just remove it and put you could just leave it like that, or it won't change anything. This is just the default way they have it set up. Yes, but as I've explained already, methods are just sort of these code holders where you can use you can type a bunch of code in it and call this method to on something else in another piece of code where you can have other things happen, right? Sort of just how we in our previous file we call add force. It has its own. It's from the class rigid body and it has its own code within it, and we're able to put values into that method and something happens, which it adds force to our player. That's what we're doing for this for this part. We're gonna be adding code so that whenever our player hits the wall, we restart the game. And in order to do this, we type in scene manager dot load scene manager. Yeah, they got in the way. Dot get active scene parentheses dot name semicolon. All right, so basically what this line does right here is that the library we had, or we just imported, has a class called scene manager. We're calling a method called load scene. As you can see, the parameter says string scene name. Basically, we have to put in some word or something that represents a string of words. So that's the type of variable we have to put in. And I actually didn't type any words or anything in here because you can. What we want to do is you could actually type in something in there, right? You could do something like this, and you can type in the scene you would like. But the reason I put this long method name, or I put scene manager, I called it again, and I call a different method called .getActiveScene. So basically what this does is it gets the currently active scene that we're on. So the scene we're currently using, right, if we go back to the Unity editor, it gets this scene we're on, the sample scene, as you can see right here. This scene that we're currently viewing, it gets that. And what does it get? It gets the name. And the name is a string. It returns the name of the scene that is currently active in the game or app. So whatever scene you're on that's active, it's going to get that name and put it into this load scene parameter. So you can just basically, it's the equivalent of just typing this word or name sample scene in there. You could just type it in the quotations and it would do the same thing. But the reason we want to play it safe by adding this is that in case you ever do make any changes to your actual scene names, you wouldn't have to actually go back to all your code and retype it, like sort of hard code your code already. You would just already have this method that just does that for you, and it just accounts whenever you would like to change it. So that'll just make things easier for us. But we won't be changing it. This is just more of a convenience and better way, or professional way of coding. Just a sort of like tip. But it also works the other way. All right, so that's all we have to do. We just the whole point of this on trigger enter is that as soon as we hit that wall, as it says right here, on trigger enter is called when the collider other enters the other trigger. Collider other would be the player. Just think of this other it's the player that we're going to be controlling that's going to hit the wall. And we don't actually have to call or use this variable in here because as soon as it hits it, we're just going to load the scene. And there's nothing else in our game that's going to be touching the wall that would like affect that. So for example, if we had enemies and they touched the wall, we wouldn't want that to reset the game. But we don't have to really change anything specific here. We just need to make sure that whenever the player hits it, it reloads. All right, let's go back to our scene here. Wait for it to load in a little bit. And now we can go to our obstacles. Make sure we have everything set up for our scripts, because if you don't have one set up correctly, you'll notice that when you actually test it, it won't actually work. All right, so let's press play. And let's see what happens whenever we touch the wall. Oh, look at that. It looks like our player is reset to where he originally started. So, and the thing is, we want to check all the walls. So this wall works. This obstacle works, right? This one works as well. And we just want to check the last one and make sure that when we touch it, it resets. All right, perfect. So now we have all our obstacles working and our player moving. Last thing we need to do is make sure that whenever we touch that yellow block, we reach the end goal. We want to beat the game, or we want to tell the player that we won the game, and do you want to play again, or would you like to exit the game? And we also don't want to have the person playing the game being able to control a player once they touch it, right? We want to delete the player or get rid of it, or make it so that they won't control it, so we're telling them that this is the end of the level and there's nothing else you can do. So in order to do that, we want to create another script. So go into our scripts folder, right click, create C# script. And for this one, we're going to call it win. So this will be our script that controls what happens whenever we touch the exit, the yellow block, or cube I should say. And that would be our code in here. So we double click and go into it. Or actually, before we code anything, go back to the editor. And as we've done before, click on the exit object, which would be our cube in our hierarchy. Drag and drop the win script onto the exit object. And as you can see, once it's added, you can see down here, win script has been added. So now we have that. And we also want to make sure, since we're going to be colliding to it as we did with the obstacles, we want to make a trigger. So under the box collider component, make sure to click this trigger on. And there we go. Now we're ready to code. So go back into your editor, your scripting editor. And now we're going to be adding the code to see whether we see some sort of text. We want to show the players something visual that they can know that they won the game. So the best way I would approach with this is or the simplest one would be just to pop up some text that says you won the game, would you like to restart? So and also if they choose to restart, we want to reload the game. Or if they want to exit, we want to close the game. So in order to do this, let's add the same import we did last time, scene management. This will be for the reloading the game. We want to have a library. And a new one we're going to add is Unity Engine, oops, my bad, .ui. So basically what this one is going to be about, UI stands for user interface. So basically what we're looking at right now in our editor is a UI. It's a user interface of being able to move around or create files, code, type. You have all this highlighting. You can click on, there's buttons, tabs, views, right? All these little options we have here. This scroll bar, everything. This is all a user interface. This is something we can see. It's not just writing text. Or if we only had this available and you can picture none of this around you and just purely this, sort of like a command prompt, right? If you're to type in the command prompt, all you see is just text. Whatever you type in, there is no buttons or anything. So this editor we're using is an example of a user interface, and that's what we want to add to our game. Not something as complex as this, right? But we just want to add a piece of text to the user and just tell them that they won the game. So in order to do this, we need to create some variables. We're going to start off by saying public text, win text. And basically what this one will do is that we're going to make a variable called win txt. Txt stands for text. This is a short way of writing it. It's going to be of type text because that's what we just talked about. We want to show the player a piece of text to the game or the screen. And there's a class for that called text. It just is special. It was made just so you can show text to the player. It's part of the interface library. And public, well, we want to be able to use this text variable, right? We want to use that text object anywhere we would like in our game or an editor. So we want to make sure it's accessible within our editor. If we made it private, it wouldn't be. So we make another one. So that's for our text, right? Now we want to make one for our player, game object player. And the reason we're doing this one, right? So we created a variable called player. It's of type game object. Game object is basically what I've already said before. It's everything that's within your hierarchy. Every single thing within your hierarchy is a game object. So now we want to modify that. We want to modify the player directly, and we need to call a type object for that. And we want to make this public accessible everywhere in the editor, or anywhere I should say. So let's see. The next thing we're going to do is we're not going to be using the start method. We're not doing anything in the beginning. We want to constantly check in our update, or we want to check certain things. So we're going to be using the update method. So the first thing we're going to do is type if input dot get key parentheses key code dot r. Alright, so basically what this piece of line of code does, or several lines of code I should say, we're introducing a new type of concept in our coding. This is also part of the C# language. An if statement starts off by writing the word if. You write in you have a open parentheses and a closing one, and anything that you put in here is a condition. So the idea for an if is it's a condition. So basically, you want something to happen, and if this, let's say, you wanted if your character were to fly, let's say if your character flies, what happens next? Or if it doesn't fly, what would happen because of that? Maybe if it flies, you want to make sure there's gravity, or if it flies too high, you want to make sure it doesn't fly above a certain height. So basically, if this happens, then do this. That's the idea of an if statement. It's a condition. You want to check something, and if that is true, continue on with the result. If it's not true, don't do it. Right, so we want to check here. If we're going to use our input class, .getKey. Basically, it says returns true while the user holds down the key identified by the key code enum parameter. So basically, this is just going to check whether we are holding down a certain key, and in this case, R, right? If we're clicking the R button, we're going to do something. So when we click the R key on our keyboard, we want to do something. And for this, we're going to be accessing scene manager, .load scene, parentheses, scene manager, .get active scene. Oops, that's not what I wanted. Get active scene. .name and close it. So we already went over this. This is just going to basically reload our game. So if the player wants to play again, they just click R at any time they want. It doesn't have to be at the end of the game. It could be during the game if they mess up. But they might not know that their first time they play, so we'll have to explain to them once they win. So we'll create another condition. Input.get key code. And the thing is, whenever you want to retype something that looks very similar to the last thing you typed or the last piece of code, you could just copy and paste and just sort of change what you're going to have different in the next one. But in this case, for the tutorial or documentation, I'm just going to be doing it. I'm just going to be retyping it. Alright, so for this one, we're going to be using the escape key, because whenever you actually, if you go back, click on the dot, you have I'll show you a list of options on all your keys on your keyboard. So, but we're going to be using escape because we want to exit the game, and we want to click the escape button. It just sounds right if you were to click the escape button to exit an application. Most applications, you click the escape to get rid of or get a full screen, or actually just close the game, or show a menu that would be the pause menu, and you would exit. But in our case, we don't need a pause menu. We just want to exit the game if we're done. All right. So in order to do this, we're going to call a class called application. We're going to call a method from that class called quit, and just that's it. Quits the player application. It's simple. We have a class that called application that will basically get the application we're running, which will be our game, and it has a method called quit that will just quit the application we're running, which is our game, and it'll just close it. And we won't be able to demonstrate this in the editor. You have to build your game into an actual application as if you were using anything else on your computer. But we'll do that at the very end when we're done with the game. It will work though. All right, so we're done with the update class. Now what we want to do is, once we hit that exit block, we want to check when we hit it and what happens when we hit it. So we're going to call our WinText variable, we'll call our WinText variable .gameObject .setActive is equal to true. So basically, we're going to call our WinText variable, right? Since it's a type of an object type of a text object, class object. It has methods within it. So one of the methods is GameObject, and basically what we want to do here is get the GameObject of this text and set it equal to true, because we're not we have it as of type text, right? Not as of type GameObject, because we want to be able to use other features from this class. But since everything in our hierarchy is a GameObject, this is still technically also a GameObject. So that's why if we specifically state .gameObject, we want to modify a property as if it were a GameObject, because it is, but it's primarily just seen as a text by the editor. So the reason we're doing this, we're going to call a method called setActive. Whenever you use this method, it has a true and false Boolean value. And the Boolean value is just whether it's true or false, right? You want something to work or not, turn off or turn on. Um, so we want to basically we want to show the text to the player or to the user whenever we win. Otherwise, do not show at all. So why am I setting it to true only whenever we win? Well, we're gonna have it off the entire time until they win. Initially, before when the game starts, it's gonna be not visible or invisible, I should say, and we'll only show it whenever we win. Last thing we want to do is call a destroy method, and this will destroy the player. We just call our player variable we made up here. So basically what this does is it removes the game object, component, or asset. And that's what we're trying to do here. We want to remove the player entirely whenever we win the game, so the person that's playing it would not be able to control them anymore, and just know that it's either time to restart if they would like to, or exit the game. And that would be the option. Alright, so oops, I accessed something here that I was not supposed to. Yeah, there's actually when you click on these piece of little notes here, you can sort of just actually see where the code is for some of these things that's already in the engine, and that's what happened right now. But we won't be looking at that. So click on Control S on your keyboard to save your file here, and then we would go back to our editor because we're actually done here. We already made everything we need. Let that load in. And then now when we go to our exit, we can see down here we have two slots here: win txt and player, which are these are the two variables we made public so we can access them here. And they say none because we haven't placed anything in these. There's nothing in them. They're empty variables. So in order to fill them up, all we have to do is just drag and drop them in there. Click on your player. And when you see, whenever you click on this hierarchy or anything else, you lose whatever you see on your inspector. And this can be a little, have a little trouble or be a little annoying. So what you want to do is, you can just make sure it's selected. Quickly select the player and drag it in. Or click on your object that you want to put something into. Go right here in the top right. There's a little lock icon. Click it. So now whenever you click on anything else, it'll always stay there. Click on the player, you would drag it, and there you go. But if you click anything else, it won't change. So you want to make sure that if you want to change anything else, you have to unlock it. Right, so there you go. Now you can see different ones. But it's a little convenient thing to have because it can be a little frustrating to have it disappear whenever you're changing things. Alright, so now that we have that ready, we still have to make this text variable, and in order to do that, this is a text variable that we're going to be showing to the player. So this is something new. Right click on your hierarchy, go down to where it says UI, click on text. And now as you can see, we made 3 new game objects here: a canvas, a text, and an event system. So basically the event system is going to be, if we were using buttons, if we created buttons in our game, some type of other UI, because we could actually, create buttons, right? There's a button option here. It would get the control for that. So basically, if you were to click on it or tap on it with your finger, if it was a game for a mobile device, it would detect that. But we're not going to be using that here. We're just going to show text. So we're only going to be using these two. So the first thing is the canvas, right? Now, if we double click on it to zoom in, we can't really see anything. Even if we try to move in here, it's just nothing seems to be working, right? We can't really move. Why? Because it's a 2D view, right? This is a piece of text that we're showing on the screen, and we want to be able to see that. And we can, but we want to change the dimension we're in. We're in a 3D dimension or perspective. So if you go right here, under the game view tab, there's a 2D option. When toggled on, the scene is in 2D view. When toggled off, the scene is in 3D view. Click on it. And now we can see in the 2D view what our canvas is. This canvas is basically going to fit in our game here. As you can see, there's already a default text. This is the text added, and it's right here in front of the game in the game view called new text. So just think of this square, or this canvas square within our 3D game view when we're playing it. But we're looking at it in a 2D view because that's where the text is. It's in the 2D space. So let's make this text work for what we want to show to the player. But before we do that, actually, we have to account for some things in our canvas. So the first thing we want to do is click on canvas, go to the inspector, go down to where it says canvas scaler. We're going to change this option under UI scale mode to scale the screen size. Now the reason we're doing this is because we want to have our UI, anything we have, right? Text, buttons, whatever we would put in here, we want it to scale correctly with whatever screen size we're playing the game on. Because if you don't do this, it's going to be like too big or too small, or just won't be in the right spot on your screen. It'll just look really weird, and it just won't look right whenever you're playing your game on whatever screen you like. We want to make it accessible to all types of screen sizes to fit in the right spot. So for the base resolution, or the reference, which would be our highest, I should say. Yeah, well, this would be our reference resolution. We're going to make it 1080p. So for our reference on our X, type in 1920. For our Y, we're going to put in 1080. And this will create our highest HD resolution that we can go off by. So anything from here and below, it would support it. And that's basically it for our canvas. We just want to make sure we fill in that. Control S to save that. And now let's go to our actual, or, well, we could do this at either side, but I said, no, we can do it right now. All right, so let's go to our game view. Before we'll work on the text right now, but I'm trying to make sure that before we actually modify anything on our canvas, we want to make sure that everything's going to work well for all devices. And you'll know this mistake, or you'll realize that you want to do this beforehand, because it'll be, like I said, very frustrating to sort of go back and fix everything you already did. So as you can see, when we modified our reference resolution, our screen or our piece of text became really small, because now this box really it got way bigger for our game. So now we want to go to the game view, or game tab I should say, right? Click on the game tab. Right here where it says standalone, or it might say free aspect for you guys. Just drop down right here in the middle, right next to display 1 and before the scale. Click on it. It'll give you a bunch of resolution options for you to look at the game at. And we want to look at this at the max possible, or the reference resolution we're looking at. So we're going to call this 1920 by 1080, right? That's going to be our label name. We're going to leave the type as it is, and this is the important part. The width is going to be 1920, and the height is going to be 1080. Click OK. And there we go. Now we can fit everything in the reference resolution we put. And you can add many more by just clicking the little plus button and just selecting it. The little check mark says which one you're using. Alright, so now we're looking at the game view at the 1920 by 1080 perspective here. Alright, so let's go to our text. Now we can actually modify our text. So first thing we want to do is click on text, go to the inspector, scroll down, and right here where it says text in the little box, it says new text. This is where we can type to show to the player what we want to tell them. And in this case, we want to just sort of say you win in caps. Click enter to go to a new line. Press R to restart. Press ESC, or escape button, to quit. So now we have that showing, and as you can see, if we were to use our scroll wheel on our mouse, it doesn't really seem to be showing everything we just typed, because our text box here, if we hover our mouse over these blue circles, if we drag it out, now we can fit everything into it. If we click on game view, it's still rather small. So in order to fix that, we have an option here in on our inspector under character, this character heading. We have a font type we can change, but we have a font style we can change, bold or italicized, right? A font size. This is kind of like the options you might see in like Word, if you guys have used Word before. Font size, this is the one we want to change to look nicer. I have a value I think that should look nice for 60. And it won't show again because you have to increase your text box size to sort of just show that here. Oh yes, that looks really good now. The only thing we want to make sure is that, oh well, actually it's not showing everything just yet. So you can drag this left and right and up and down. So let's make sure, there we go, like there we go. All right, maybe right here. No, probably a little bit more over here. It's a little too big. Let's see, if we were to close it more like this, how about like this? No, All right, so 60 might be a little too large, a little too big, so maybe 50 might be good enough. Yeah, I think 50 might be good enough actually. Okay, maybe not. Wait, right there. Maybe it's a little too big still. All right, so we can fix this by just lowering it down just a little bit more. 45 maybe. 45 seems to barely cut it. And the thing is, with you just sort of nitpicking and messing around with these values so I can show correctly to your player. Perhaps 40 would probably be the best option here. Yes, 40 seems to be really good. There we go. Maybe align it a little bit more like this. There we go. That looks great. So we're gonna have our font size at 40. I initially had it 60 under my notes, but I must have had the I think that was before I had changed the game view. See, that's the thing. You might have a wrong orientation or size if you change the game view after you made this change to your text. So make sure you always change the canvas, your scalar to the screen size and the reference resolution first, and your game view. Make sure to set that to that reference resolution before you start anything in your canvas or your user interface component. All right, so now we have our text shown. Last thing we want to do is sort of just not show this to the player whenever we are playing our game. So what we want to do is click on this little, or click on the text object if you're not already on it. Go to the top, and well, before actually we turn it off, let's go to our hierarchy. Click on our exit game object, and we want to drag and drop this text object we created, right? So click on the little block icon here. Drag and drop the text object we have from our canvas into the win.txt slot. So that's the text object we want to put in there the entire time. This is the one that's going to be showing, or back in our code, right? We're going to be only showing to the player when they touch or they run into the exit. So right now it's always going to be showing, right? So if we were to, play the game, it's already showing. We don't want that. So we want it to disappear. So in order to do that, let's go back to our text game object, and I forgot to turn off the lock. Make sure to do that on the top right up here. Go to your text game object, go to the top, next to the name of the object, click this little check mark. This will be this is the set active method we were talking about in the code. If you click the check mark, it's off. So just think of that as set active false. And whenever we hit or run into the yellow cube, the exit, we'll set it back to true, which will turn it back on. So right now it's not visible. So now if we play the game, it's not there anymore. So now if we were to actually, let's see if we can make it to the end without dying. Because realistically, we have just about everything we would like done. And I died, unfortunately. But that's good because it just shows that we're testing our game and everything's working out correctly, that the obstacles actually kill us. And there we go. The player gets destroyed from the scene. If you were to go in our hierarchy while it's running, it's no longer in here because we destroyed it. And our text appears. If you go in here now, the check mark is active. So now when we click restart R, we restart again. And there we go. We have our game complete. The only last things to do is check whether when we click the ESC button, the escape, it closes our game. And we sort of just already want to make a build, an application that we can actually play on our computer rather than always testing it within the editor. So now that we've gone to the last part, let's finally compile and build this game, right? In order to do this, go to the top left, click this button called File. We want to go to Build Settings. And now, where it says Scenes in Build on the very top, there's a scene/sample scene. So basically, this is our scenes folder that I was talking about earlier, and in it is the scene we've been using called sample scene. We want to include this in our build because if we didn't include this, basically our project would not be building anything. It would not be using any scenes at all. You can have multiple scenes in your project because those are like multiple levels and screens you can have your game in, right? If you want to have multiple levels, you want to have multiple scenes, you would check mark all the ones you would want. And we only have one right now, so we want to make sure this only one is in the game because that's what our game would be. Without it, we wouldn't. It would just show like a blank screen to our player. So make sure you check mark that so the game can or the game engine can build it. Make sure our platform's set to PC, Mac, and Linux. We're developing this game for computers. Make sure no, the rest of that should be already correct and ready to go. So click on build. Now it's going to take us to our project directory where we have our project saved on our computer, and it's going to ask us where would we like to save this game, or the build I should say, the build we're going to make. Where would we like to save it? We want to create a new folder. Click on new folder, call it builds, right? So now we have a builder called this folder is going to be dedicated to having all our versions and our tests of our game. So whenever we build it and test on our computer, we're going to save them in this folder. So just make sure it's highlighted. It says builds right here. Select folder. And now the game engine will, or Unity will now start building the game into an application. There might be some stuff happening in the background. It's just sort of refresh and reloading, and just putting everything you made together. And then when it's done, it will open the builds folder we just made, and it creates 5 files here. You need all these 5 files to run the game, right? If you'd like to share this with friends or anybody or publish it, you need to make sure you include all these together, not just this one. So now we're gonna click on this one right here, double click on it, and now it will run. Alright, so now we have an actual application of our game here. Let's play it out. We can die by our obstacles. Can we restart? We click R, yes, we can restart as many times as we want. Alright, let's see. Make it around. And there we go. We can restart. If you want to quit, just press escape and it closes the game. And there we have it, guys. We completed and made a full simple game with Unity. And this was a really simple idea or game idea that I wanted to just sort of go with because there wasn't really anything else I could have explained any easier. There's a lot of beginner tutorials out there that you can find on YouTube or online courses that you can pay for that really go way more into depth on things that I might not have gone into. I just sort of focus more on explaining how to use the basics of what this game engine can show you, the editor, the code. Most of the other ones will go more into depth already, like as if you already knew some of the basics already. A lot of them don't really go into, or they don't really put everything together. They sort of have everything separate, which is probably better because this video is going to be rather long. So it can be very exhausting and tiring to be watching it all at once. But in the future, I plan to make more professional videos that would separate each category into separate videos, so it'll be easier to remember and learn. But yeah, this will be our game. Simple little controlling a sphere to reach and exit. That's the main goal of the game. We just go around obstacles in our level to reach and exit, and that's our winning state. And we can restart and exit, sort of control that. But yeah, that would be it for this tutorial and documentation project. Thank you guys for watching. I hope you guys enjoyed it. Goodbye.